Hey everyone, welcome to your learning journey in this natural language processing. Now, in this video, we are going to look into the applications of NLP in real time, and we'll also look into the tasks that we can do with the help of natural language processing. And now, when I talk about this natural language processing, one thing that we generally come across our mind is the virtual assistant. I'm sure you have interacted with most of the virtual assistants that we have got out there. To illustrate the same, I'm going to say, Hey Siri, what's the weather today?
Looks like rain today. Daytime temperatures will hover around 25 degrees with overnight lows around 18 degrees.
See, I've been able to interact with the Siri as of now with the help of my natural language. And I can do the same thing with Alexa as well. Hey Alexa, what's the weather today?
In Bengaluru, it's 69 degrees Fahrenheit with cloudy skies. Tonight, you can expect thunderstorms with a low of 67 degrees.
And the best thing is, see, when I wanted to communicate and interact with these virtual assistants, I was not using any programming language. I was actually using my human language, my natural language as a medium of communication to interact with these virtual assistants. Now, that's the way in which that we are progressing in the world of natural language processing. But the question that we might have on our mind is like, you know that when we talk about computers can only process the data in the format of binary, that is zeros and one. But when we are talking about our natural language, it's not represented in the format of the zeros and one. Do you agree with me? Yes, our human language is not represented in the format of binary. But the question is, how can we ensure that these machines can understand our natural language? Yes, that is where the natural language processing comes into picture. Now, this natural language processing is an area of computer science with the methods to analyze, model, as well as understand our human language so that our computers can process the same. Now, you can consider any intelligent application that is out there. So, if that intelligent application has to analyze our text data or our language, then it has to have NLP component inside it. One thing that I have mentioned, which is important for you to remember as of now, is when I talk about the virtual assistants, like the digital assistants like Alexa, Siri, and Google. So, all these things, whenever I'm communicating with those applications, I'm using my natural language and not my programming language. And this natural language processing, this is one of the important component in wide range of software applications that we see right now in our day-to-day life. Now, if I want to name some of the important applications in our day-to-day life would include, I can say email platforms. So the core applications of this email platform, it actually uses the NLP to provide a range of product features. It would be spam classification, priority inbox, calendar event extraction, auto completion. So these are some of the important applications of NLP in our day-to-day application of email. And if I want to talk about the virtual assistants like Apple Siri, Google Assistant, Microsoft Cortana, and Amazon Alexa, they actually rely on the range of NLP techniques to interact with the users. And while interacting, it will help this NLP. So while interacting, it will help these devices to understand the user command as well as respond to it in a correct manner. Not only that, even the search engine like Google or Yahoo, so it uses natural language processing to understand what exactly the user is actually giving as an input, and based on the user's input, it is going to generate the response. And the other applications where we see NLP a lot is the applications like machine translation. So machine translation is a service which is available in Google. I'm sure everyone has experienced it, where you will input the text in one language, you will get the output in another language. And here, this NLP techniques are used in the applications like customer service, where the companies use this NLP techniques to give the better service to the customers by employing the chatbot. As you can clearly see, natural language processing is used in variety of industries as well as variety of application. Hence, I would say natural language processing is one of the key thing that every data scientist or every person has to know in the data science world, because it enables us to understand and extract the information from the text data. As I've already mentioned, if I want to describe what exactly is this NLP, it's an area of artificial intelligence. Here, it takes the raw written text, which is in the natural human language, and interprets and transforms it into the form that my computer can understand. So it's a technique which will help the computers to understand our human language. Now, when we talk about this NLP, so this NLP is used in variety of application to do variety of tasks. Now, this is a common set of tasks that we generally do it with the help of this NLP, that is natural language processing. Now, remember, this is not the exhaustive list. So these are some of the frequently occurring tasks that we generally do it with the help of natural language processing. Okay, if I want to quickly name those tasks, we've got language modeling, we've got text classification, we've got information extraction, information retrieval, conversational agent, text summarization, question answering, machine translation, and topic modeling. So these are some of the commonly performed NLP tasks. Here, while dealing with the text data, so we can perform all these tasks with the help of natural language processing techniques. Now, let's get some deeper understanding of these individual tasks, so that as we start working on these various tasks in the upcoming learning journey, you'll be able to better connect to the respective applications. Okay, so let's start with language modeling. Now, when I say language modeling is a task of predicting what the next word in a given sentence will be based on the history of my previous words. Here, I'll have a simple goal. The goal is to learn the probability of the sequence of words appearing in a given language. That's it. And this simple task is used in building the solutions for variety of problem. So this would include speech recognition, optical character recognition, machine translation, spelling correction. So these are all some of the applications of language modeling. Now, the key thing that you have to remember is I'm trying to predict what will be the next word in a sentence. So that is what we call it as a language modeling. Next, we've got the task that I've mentioned as text classification. Now, this is a task of classifying or categorizing my text into a known set of categories. Here, this text classification is one of the most popular tasks in NLP, and people will think that text classification is the only task in NLP, but not. Text classification is one of the tasks in natural language processing, and this is used in variety of tools. It could be email spam identification, sentiment identification, or sentiment classification, and so on. So these are some of the tasks or the applications which is used for the task of text classification. Moving on, the other task that I have mentioned is information extraction. As the name clearly indicates, this is all about extracting the important and the relevant information from the text data. It could be the calendar events from the email, or names of people mentioned in a social media post, or it could be the names of people mentioned in an email, and so on. So this is about my information extraction. It's all about extracting the information from the text data. Here, the moving on, the next task that we have got is the information retrieval. As you can clearly understand from this name itself, it's all about finding the documents which are relevant to the user's query from a large collection or my large database. Now, the applications of this information retrieval are Google search. So it actually uses the information retrieval technique to generate the result on the basis of the user's input. Now, apart from this, we've got the conversational agent. Now, here, when I say conversational agent, it's a task of building a dialogue system which can converse in a human language, that is our natural language. Some of the applications for this conversational agents are Siri, Alexa, Google, and so on. So these are some of the applications of conversational agent. Okay, and we have got the next task, that is my text summarization. In the scenario of my text summarization, this clearly aims to create short summaries of longer documents by ensuring that it will retain the core content of my entire large text. So this will ensure that we will remember the important things from the given large sentence, but also reducing the length. So that is what we call it as a text summarization. And the application of this text summarization are summary report generation from the social media information. So that's one of the application of text summarization. And here we've got question answering. Now, this is a task of building a system which can automatically answer the questions which are posed in a natural language. So here the example can be a chatbot, or the another example can be responding to the user's query or the user's question on the basis of my existing database. So that is a task of question answering. Then the machine translation. So the machine translation is a typical task of converting a piece of text from one language to another language, and the application is Google Translate, which we generally see it and which we use it on a day-to-day basis. Okay, then the last one that I have mentioned was topic modeling. Now here, when I say topic modeling, it's a task where we will try to uncover the topical structure of a very large collection of my documents. This is one of the common text mining tool, and we generally use it in variety of domains. It could be from literature to bioinformatics. So generally we use it to find the important parts in a given data. Okay, so as part of your learning journey in this video, you have learned the wonders of day-to-day world. So you have realized that with the help of NLP, we have seen the amazing applications that are around us, like the virtual assistants like Alexa, Google, or Siri, and its usage in real time, and the various tasks that we can do with natural language processing technique. Now, as we proceed in our learning journey, in the next video, we will understand why human language is so special, and we will look into the basics of human language, which will help us to appreciate our human language as well as understand the complexities that are involved in this human language, which will motivate us to learn more about the natural language processing techniques. I hope you guys are as excited as I am. So I'll see you in the next video. Welcome back to your learning journey in this natural language processing. Now in this video, we are going to understand our human language. So as we proceed in today's session, we will look into the language and the linguistics, and then we will look into the building blocks of a human language. First of all, let me ask you this question. What exactly is a language? So I can say language is a principal method of human communication. And in this language, it is consists of words, which is used in a structured and a conventional way, and it is conveyed by a speech, writing, or gesture. So overall, I can say that it's a structured system of communication, and this involves complex combination of its constituent components, that is my characters, words, sentences, and so on. So language is something that we use it for communication. Now here in this language, as I mentioned, it is made up of important components like characters, words, sentences, and so on. Now that you have understood a language, now there are various languages that are being used by humans. Just to give an example, English is a language, French is a language, German is a language, Kannada is a language. See, these are all the various languages that we have got. Now it's a method of human communication. Now if I take up the example of English, English has its own set of components. English has the set of characters, English has the set of words, and I'll be using multiple words in a specific sequence and in a specific order to form a sentence so that I can convey a meaning. That is what a language is all about. It's a method of human communication. Now, where does the linguistics comes into picture? Well, linguistics is a scientific study of this language. It's a scientific study of the language and its structure. And this would include the study of grammar of that language, syntax of that language, and phonetics. And that is what linguistics helps us in studying the language which we use for human communication. Now that you have understood what exactly is a language and the linguistics is, let's look into the building blocks of a human language. When I talk about this building blocks of a human language, there are majorly four building blocks. They are phonemes, we have got morphemes and lexemes, syntax, and context. So these are the four building blocks of a human language. And phonemes is made up of speech and sound. Morphemes and lexemes is related to the words. Syntax refers to phrases and sentences, and context refers to the meaning. Now here, when we are working with any language, we should be aware of these four building blocks that will actually help us to effectively use that language for communication purpose. And even if you remember from our primary school, if I take an example of English language, we started with very basics. We started by understanding as how to make a specific letter sound. For example, aba, kada. And then we started using those characters. We started using those sounds to make a meaningful word. Then we use those meaningful words together to form a specific sentence. And then we started understanding those sentences by looking at its meaning. Hence, we call these four are the building blocks of any language. And whenever we are building any natural language processing based application, we will be required the different levels of understanding and different levels of these building blocks when we are doing the implementation. Now, let's take a deeper dive and let's understand about these four building blocks of a language. So let's start with phonemes. Phonemes are the smallest unit of sound in a speech or a language. And here, if you just think about it, these phonemes do not have any meaning by itself. But this can induce one sound or it can induce a meaning when it is uttered in combination of other phonemes. For example, the word E does not have any meaning over here, but I can use it in a word or I can use multiple phonemes together to make a sense or to specify a meaningful word. For example, sheep. Now talking about an English language, we have got 44 phonemes. Now here, the application of phonemes are in speech understanding, speech to text transcription, and text to speech conversion. So these are all the applications of phonemes. So whenever I'm building the applications which are related to these applications, then at that time I will be interested in the phonemes block of a language. Moving on, I have mentioned that as a morphemes and lexemes. Morpheme is the smallest unit of a word, and this provides a specific meaning to a string of letters, that is my phonemes. And remember, not all morphemes are words, but all the prefixes and the suffixes are my morphemes. To give you an example, see in the word multi-story, so this word multi is not a word, but it's a prefix that changes the meaning when I put it together with the story. Hence, I can say this particular multi, I can call it as a morpheme. So this is just to give you a high level idea about what exactly is this morpheme team. Now talking about lexeme. Lexeme is now something which is the most basic building block of a language. Now, if you open any typical dictionary, the entries that you see over there, they are actually called as lexemes. So I can say these lexemes, they actually have variations and this build upon the basic form. For example, walks, walked, walking. So this is about my lexemes. Now, whenever we are building the NLP based applications, so these morphemes and lexemes are actually used in the techniques like tokenization, stemming, lemmatization, word embeddings, as well as part of speech tagging. Now, you don't need to have a deeper understanding about what exactly is this morphemes and lexemes. You just have to know that morphemes or lexemes are used in the applications like tokenization, stemming, lemmatization, and the others that I show here on the screen. That is what you need to remember from the NLP perspective. Moving on, we've got syntax. Now, when I say syntax, syntax is nothing but it's a set of rules that determines the arrangement of words in a sentence. Now, in this scenario, if I want to represent a sentence and to represent it in an efficient manner, we make use of this parse tree. Okay, now we use this syntax generally for the applications like entity extraction and the relation extraction. Now here in the screen, the diagram that you see right here, this diagram is the one which represents the syntax of a sentence, and this is determined and this is represented with the help of parse tree. If I want to give you more information about this parse tree, so parse tree is something which represents my hierarchical structure of a language. And if you look into this parse tree, which is the way that we represent the syntax of a language, so here we will have the words at the very low level. Then this is followed by the part of speech tag. We have got determiner, verb, noun, and so on. Now this is followed by the phrases. We have got noun phrase, we have got verb phrase, and so on. So we have got noun phrase, verb phrase. NP refers to the noun phrase, VP refers to the verb phrase. And at the end, I have got the sentence at a highest level. Now, this parse tree representation is a language specific, which means the example parse tree representation that you're seeing on the screen, this is for the English language. Now, if I'm dealing with a French language, then at that time, I will have a different representation of a parse tree. The reason because in the scenario of French language, I'll have a different phonetics, I'll be having the different morphemes and lexemes. So I'll be having a different set of rules over there in the French language, which is specific to that language. Hence, we will say this parse tree representation as a language specific one. Okay, moving on. The last building block which I have described was context. Now, context refers to the words and sentences that surround any part of a disclosure, and it actually helps us to determine its meaning. Now, this context would include the long-term references, word knowledge, as well as common sense. Now, here, when we say context, contexts are actually made up of semantics, which are nothing but the direct meaning of the words, pragmatics, which refers to the adding the word knowledge and the external knowledge, and the applications of this context would include sarcasm detection, summarization, and topic modeling. Now, to give you an example for the context, if someone says that the bank is going to lend the money when you say that you do not need them, now at that time it's a sarcasm. So it's a context saying that bank will be ready to give you the money as a loan when you are aware and when you have enough money and when you are financially stable. Now, in order to detect those kind of sarcasm which is present in the underlying sentence, so we need to understand the context. Okay, so that is the importance of context. So here, as part of today's session, you have understood what exactly is a language, which is a principal method of human communication, and this is consisting of characters, words, sentences, sounds, and so on. And you have understood linguistics, which is a scientific study of a language, and you have also understood the four major building blocks of any language. phonemes, morphemes and lexemes, syntax and the context. Now, as we proceed in our next video, we will look into the challenges of natural language processing. Why is it so challenging and why is it rewarding as well? So we will see everything in detail as we progress in the next video. Hey everyone, as we progress in this video, we'll look into the challenges of NLP. So what are the key challenges that we face in this NLP area? Now, if I want to describe the key challenge in NLP, I can say that the ambiguity and the creativity of the human language are just the two characteristics that I can say which makes the NLP a demanding area to work in. To give you an example, let's take up a deeper understanding of these characteristics. Let's start with ambiguity. Now, ambiguity means presence of two or more possible meanings in a single passage. I can say it's an uncertainty of a human being. Now, whenever we talk about any human language, most of the human languages are inherently ambiguous. So just consider this example. Suppose if I have a sentence that say as we saw her duck. Now this can mean actually two things. It can mean that we saw her lower her head, or we saw the duck which is belonging to her. Now if I ask you what is the correct meaning or what exactly is the one that is being conveyed in the sentence, so here this would actually depend on the context in which this sentence would appear. Do you agree with me? So depending on the sentence that is being, depending on the context in which this sentence is being occurred, then depending on that, the meaning would change. It can either mean the first one or it can either mean the second one. And that is one of the key challenge that we have got with natural language processing. And another disadvantage or the challenge that we have got with our human language is this common knowledge assumption. Now, when I say common knowledge, so it actually refers to the set of all the facts that most humans are aware of. And it is assumed that these facts are already known. And I can say this common knowledge is one of the key aspect of any human language. Now, suppose I'll give you an example. Suppose if I say that sun rises in east and sun rises in west. Now, if you look into both of these sentences, now for a human, it is very easy for me to identify that this is not at all a possibility, because from my common sense, I'm aware that sun always rises in the east. Sun cannot rise in the west. So I know as a matter of fact that the first sentence is the one which is a correct one, and the second sentence cannot even happen. But if you ask the computer to come at the same conclusion just like that I'm doing right now, then at that time it's very difficult for the computers to process the same. And this is another challenge of NLP that we have got. And the next challenge that I would say when we are working with this NLP based application, especially with the human language, is the creativity. As you know, we humans are creative beings. We love to create new things. We love to come up with our own ideas and we want to convey it in a special way for a special one. So, when you take up any poem, at that time, how do you convey the meaning of those poem and its underlying context to the machine? And for each language, it will have its own dialect, it will have its own style, it will have its own variation, and each and everything will be unique for that specific region. Now, in that scenario, that would make very difficult for the machine to understand the creativity of the humans. So, the three key challenges that I have described right now in this video are ambiguity, common knowledge assumption, and the creativity. Apart from that, if I want to describe the other challenges which I have not mentioned in the slides, they are diversity across languages. You know that if I want to give an example in my region itself, in the place that I'm staying in, so I've got people who is speaking more than 100 plus languages. So you can think about the language diversity that we have got. And when we are building an NLP based application on the basis of human language, think about the complexity that we would come across. So these are all the key challenges that we have got in NLP. So the issues that make challenging is the one that makes a most rewarding domain to work in, that is the natural language processing. I hope this gave you a clarity as why NLP is important and what are the key challenges that we have got in natural language processing. In the next video, we'll take a look into the summary of this section, which will prepare you for your next upcoming learning journey. So I'll see you in the next video. In this video, let's summarize the learnings of this section. So, as part of your learning journey in this section, you have understood what exactly is a language and you have looked into the various applications of NLP, the challenges that we have got with natural language processing, and also you have looked into the various tasks that we can perform using this natural language processing. We have seen everything in detail from the theoretical perspective about our natural language processing. Now, as we progress in our upcoming video journey, we are going to learn about the pre-processing activity that we can do with the help of NLP pipeline. So I'll see you in the next exciting learning journey where we will have the hands-on learning session by writing the code in Python programming language using one of the most important libraries of natural language processing. So I'll see you in the next video. Welcome back to your learning journey in this natural language processing. Now in this video, as we proceed, we are going to learn about the NLP pipeline and the various steps that we are going to perform in this NLP pipeline. Now in the previous chapter, we have seen as what exactly are the NLP applications that we can build and the challenges that we are going to encounter whenever we are dealing with the text data. Now, if I ask you to build any of the application by referring to a specific task in NLP, then what you would do? Yes, just like you solve any machine learning problem, you are going to get the requirement from the business, and once you get the requirement, you are going to break down that problem into multiple subproblems. Then you are going to develop a step-by-step procedure so that you are going to tackle that problem one by one. Even in the scenario of this natural language processing, you're going to follow the same approach. But one key difference is in the scenario of this natural language processing, we are dealing with the text data or a string data. That means apart from the steps that you do with the machine learning or deep learning, there's another additional step that we have to do, that is the text pre-processing, which is nothing but converting these text data into the numerical format so that we can analyze on these text data. So in the scenario of the natural language processing, this step-by-step processing of the text is what we call it as a pipeline. Now this is a series of steps which are generally involved in building any natural language processing model. Now these steps I can say are very common in every NLP project. Hence, it is very important that you understand this NLP pipeline in detail. And that is the overall agenda of this section. In this section number 2, we are going to deep dive into the text pre-processing methods and the core NLP pipeline. Now, if I want to list down the various components of a generic pipeline of an NLP application are, see, the first component, I will say it as a data collection or the data acquisition. And the second component is text cleaning. The third component is pre-processing. Fourth component is the feature engineering. Fifth component is modeling. Sixth component is evaluation, deployment, and monitoring. So these are the main components of an NLP pipeline. As you can clearly see, it involves the same kind of steps that you would generally see in the scenario of machine learning. But along with that, we also have some additional steps which are relevant for the text data. Okay, and these components of this NLP pipeline plays a very major role whenever we are implementing any NLP application. All right, so let's get started and let's start by understanding this first component that we have got, that is data acquisition component. As you know, data is a heart of any machine learning or a deep learning system. So this data that we have, that is the one that plays a major role in deciding whether the project will be a success or a failure. And when I say data acquisition, it's a process of gathering, filtering, and cleaning the data so that we can actually use the data in an efficient manner. Now, this is a process of retrieving the relevant business information, transforming the data into the required business form, and loading it into the designated system so that we can load it as per our requirement whenever we would require for the analysis. Now, this data acquisition can be from the internal system. That means it could be from the database that the business is holding, or it could be from the external system as well, like the data that is available in the public domain, which we'll be using it for our reference. Now, remember, whenever you are working with any machine learning or deep learning based application, first you need to identify the valid source of the data, and then you have to go ahead and acquire the data. Now, once you acquire the data, you cannot use the data as it is, because once the data set is actually acquired, it will be in the format of raw data. Now, that's when the next step comes into picture, that is called as text cleaning. Now, when I say text cleaning is a process of preparing this raw text for natural language processing so that the machines can understand the human language. Now, whenever we are describing our human language, whenever you see any text data, so not only we'll be just conveying the words, we will be also using some emojis as well, some additional symbols to convey our meaning. Now, that might not be understood directly from the machine. So in that scenario, we are going to remove those additional characters, unnecessary characters, which might be due to the formatting. And then we are going to use that data for further processing. Now, in the step of text cleaning, we'll be removing the non-textual information like metadata, markup, tags, and so on. So this comes under the text cleaning technique. Moving on. The next step that we follow is the pre-processing step. Now here, text pre-processing means bringing your text into the form that is predictable and analyzable for the task. Now under this text pre-processing, we've got various techniques. We've got lower casing, where we'll be converting the text data into a lowercase. And then we have a pre-processing technique called tokenization. Now tokenization is a technique where I'll be splitting my sentence into the individual words so that my machine learning model can actually process those individual words instead of the sentence. Sentence segmentation, which is a common technique that we use it, where we'll be splitting the entire paragraph into individual sentence. And we have got stemming, which helps us in getting the word in its root form, and lemmatization also helps us in getting the word in its root form. Pause tagging, that is part of speech tagging. So these are the various pre-processing techniques that we applied on the text data so that we can work with the text data in an efficient manner. So you will learn about all these pre-processing techniques in a hands-on manner as we proceed in the further videos of this section. Now, once you pre-process the data, the next thing that you do is you will proceed with the next step of feature engineering. Now, this is an important step. The reason this is important step because this is a step where I'll be using the domain knowledge of the data to create the features that make machine learning algorithms work. Now, this is a step where you'll be converting the text data into a numerical format. Now, while converting the data into a numerical format, you will ensure that all the data that you have got is captured and represented appropriately with the help of numerical format. And this is a step where we'll be capturing the characteristics of the text into a numerical format so that it can be understood by my machine learning algorithm. And under this step of feature engineering, we've got various techniques. We've got word embeddings, we've got count vectorizer, TF-IDF vectorizer. So these are all the various techniques that we can apply on the text data to convert the text data into a numerical format. Now, once we have the data in the numerical format, then our data is ready to apply on the machine learning model. So in the step of modeling, here I'll be applying the machine learning algorithms to learn the overall pattern that is present in the data set. Now at this point, I can make use of either machine learning model or the deep learning model depending on the task that we are performing. Now on the basis of the evaluation of the data from this machine learning model, we will then go ahead and perform the deployment. Once the deployment is complete, we are going to monitor the model, and if there is any issues in the model and especially in the performance of the model, we will again follow the steps. That means we will again acquire the new data and follow the complete pipeline. Pre-process the data, feature engineering, apply the model, evaluate, deploy, and continuously monitor the same. And so this describes the overall steps that is involved in building the natural language processing application. Now in the next video, you are going to learn about the data extraction and the text cleaning in an hands-on manner. So I'll see you next time.
Hey everyone, welcome back to your learning journey in this natural language processing. Now, as we progress in this video, we will look into the working of Scrapy library, and we are going to perform the data extraction using the Scrapy library in a hands-on manner. Now, this part, that is the role of this Scrapy library, comes at the step of the NLP pipeline of data extraction. So the first thing that we do in case of NLP pipeline is we have to extract the data. And as you know, if you simply look into the internet, there's more than 40 zettabytes of data available on the internet. Now, unfortunately, a large portion of this data is unstructured and obviously it's not machine readable. That means we can access the data through the websites and technically speaking, which is in the format of HTML pages. So what we'll be doing is, as part of a learning journey in this video, we are going to perform the activity of web scraping. And here, in order to perform this activity of web scraping, we'll make use of a library that's called as Scrapy. Okay, so when I say web scraping is actually a process of extracting the structured data from the websites. And this Scrapy is a Python framework for large scale web scraping. And it's one of the most popular web scraping frameworks that we have got out there. And here I can say this is one of the great joys when it comes to performing the scraping of the data from the websites. And the main reason is, the reason that we prefer the Scrapy is it provides the tools which are required to efficiently extract the data from the websites, process them, as well as store them in the preferred structure as well as the format. Okay, now as part of our learning journey, here we are going to create a project to scrape an e-commerce website, and then we are going to extract the data from that website. It's a very simple activity and that will help you to understand what we normally do in the scenario of data extraction. Okay, first and foremost, in order to run this activity in a hands-on manner, you need to have a Jupyter notebook installed in your local system. So what you have to do is just go to the website, search in the Google as download Anaconda, and here go to the Anaconda distribution website, download it, and once you do the installation, you have to create a virtual environment. Now let me show you the steps to create the virtual environment. So steps to create the virtual environment in Anaconda. I'll show you the steps. So I'll be with you and I'll show it to you each and every step, team. Okay, so let's go and look into the documentation on the same. So first thing that I'll be interested in creating a virtual environment. Okay, so in order to create a virtual environment, so the way that we perform is, so here we will have to open our command prompt and then we will have to say conda create hyphen hyphen name environment name. Now along with that, the general practice that we do is we also going to specify the Python version. So you have to open up your Anaconda prompt, and if you're using Mac OS, open up your terminal and run the command conda create hyphen n my environment Python is equal to 3.9. So let me go ahead and do the same so that you'll have a clear idea. I'm going to launch the terminal. Now on this terminal, I'm going to write it like this. I'll say conda create hyphen n. That's a new environment that I'll be creating. And my environment name, I'm going to call it as Scrapy. That's a new environment. And here, the Python version that I'll be using right now is 3.9. And I'm going to press the enter key. Now, this is going to create an environment for me using the Python. So it says proceed, I'll say Y. So this is going to create a new environment for me. Now this would take a while because it has to take care of all the dependencies and then it has to create the environment for us. Now once an environment has been created, we will have to activate this environment. I'm going to say conda activate Scrapy. So this has changed my environment to the Scrapy. Now, once this is done, in order to work with this Scrapy web framework, so we have to install the Scrapy, else it won't work. So I'm going to say pip install Scrapy. Okay, so this is going to install the Scrapy for me. So now the installation is in progress. Now, once the installation has been completed, so we generally start with creating a new project structure for Scrapy. So the command that we generally use is Scrapy start project, and then we will specify the project name. So let's wait for the installation to complete, and then I'll show you as how we can create a new Scrapy project and what will be its file structure. So now the installation has been completed. Now what I'll do is, in order to create a project, I'll go to a folder where I want to create a project. So I'm going to go to my desktop. So in your system, you can do it at the default location. Now in my current environment, I want to create a folder in desktop and then I want to take it further. I'll go to my desktop folder and here I'm going to create a new folder called Scrapy. It's an optional step. I'll go inside that folder of Scrapy, and now here in my required folder, I'm going to start a project. When I say Scrapy start project, and the project name that I'm going to keep for this example is book scraper. Okay, that's the project name that I'm going to specify right now. And when I press the enter key, okay, so this is going to create a folder structure for me. So the reason this is important because whenever we want to create a Scrapy project, we actually have to use a specific file structure to ensure that the Scrapy knows where to look for each of its module. Now the best way is by running the command. By running this command, it is going to create a folder structure. Now to understand this folder structure, the easiest way to help you visualize the same is I'm going to open that folder using my Visual Studio so that you'll have a clear idea as how it looks like. So it is in my desktop. In my desktop, see this is the Scrapy folder and I'll select this book scraper. So here under this Scrapy folder, I have created, that means when I say start project and specify the project name, it will automatically create a folder with my project name. I'm going to select this project folder. I'll click on open. So this is just a general permission. Now once I open this, so the important thing is on the left hand side. You can look into this scenario right now. See, this is a template that we have got. And this template is the required template whenever we are working with the Scrapy project. So in this project file structure, so we have got the spiders folder. This is a folder that's called as spiders folder. And this folder contains all our future Scrapy spider files, which will extract the data. Okay, and we have got items.py. This is a Python script. So this file contains the item objects that behave like a Python dictionaries, and it provides an abstraction layer to store my scrape data within my Scrapy framework. And we've got some middlewares.py. So these Scrapy middlewares are a little advanced. So they are generally used if you want to modify how Scrapy runs and make the request to the server. So that's the overall idea as the same. So whenever we are working with very sample project or a very low level project, so we don't have to modify the middleware. Now, in case if you're working on a very large project, then I definitely recommend you to check out the documentation of Scrapy so that you learn more about these middlewares. And there's a pipeline.py. So Scrapy pipelines are for the extra data processing step in case if you want to implement it after we extract the data. Now under this pipeline, we can actually clean the data, we can organize the data, and sometimes if it is required, we can even drop the data in these pipelines. And there's a settings.py. So here we actually perform the general settings as how my Scrapy would run. For example, whenever I'm placing multiple requests in such scenarios, what should be the delay between my request? We can also set the settings like caching, file download settings, and so on. All these things can be done inside my settings.py. Okay, now for this demonstration purpose, we are going to focus on two things. One is spiders and the other one is called as this items.py. So these are the two modules which we'll be focusing on because we want to understand the data extraction at a very high level. The goal is we have to be familiar with this overall NLP pipeline so that we can effectively analyze the text data. All right, are you with me? Excellent. So let's go ahead. So here for this example purpose, so we'll specify a website. Okay. The website that I'll be using is called as books.toscrape.com. I'll show you the website right now. Now this is the website books.toscrape.com. So this is the website that we will be using as of now, and we'll be extracting the data from this overall website. We'll perform the web scraping and we are going to format the data, and we will try to store that file as a CSV file which we can use it for future analysis. Okay, we will scrape the data from this website. And here you can look into this scenario, that is this website. So here we've got all the categories that we have got on the left hand side of the screen. Okay, now what we can do is we can select the category, and in each category we have the list of books that is available right now. Okay, now in case if I want to open any book, so I can click on any book over here and this will take me to that book page. Okay, so this is the overall website structure that we see. We've got home. Under the books, we've got the various categories, and in each category, we have the number of books which is listed under each category. Okay, so that's the overall structure of this website as we see right now. And we have got the book title over here. If I want to name over here, we've got the like amount, it says whether it is in stock or not. And if I go into this book, it also has some information like what is the prototype. So you can see we've got various information that we have got in each and every page that you see on this website. Now in Scrapy, we have to store scrape data in item classes. In our case, an item will have fields like title, link, and posting time. So let's go ahead and perform the implementation of this item. Now what I'll do is I'm going to create a new Scrapy item which stores my scrape data, and I'm going to call it as a book item. To demonstrate the same, I'll open my VS Code. Okay, I'll open my VS Code and I'll go to this items.py. Okay, now in this screen of this items.py, so here you're going to create a new item class in the Scrapy. I'm going to say class book scraper item. Okay, and inside the parenthesis it is mentioned as scrapy.item. Now below this I'm going to specify the code like this. I'm going to write as title is equal to field. Okay, so what we will do is I'll say from Scrapy, I'm going to import the field. So I'll say title is equal to field, price is equal to field. Then we will say UPC, that is unique product ID. I'll mention it as a field right here. And we'll get the URL of an image. I'll say image URL is as another field. Okay. And we'll also get the URL. I'll say field. So this is how I'll be creating an item class in my Scrapy. So I'm using the default class which was present over here, that is my book scraper item, and I have modified the entries over here in the same class that we had the default class. Okay, so here in this overall code snippet, so what I have done is I have imported two Scrapy objects. So one is field and the another one is item. Okay, so item is actually used as my parent class for this class that I have defined, that is book scraper item, so that the Scrapy knows this object will be used throughout the project to store and reference the scrape data fields. And here I've also imported something called as field, and it is an object stored as part of an item class to indicate the data fields within my item. Now, once we have created this books scraper item class, so once we have created this class, we can actually go ahead and work on the Scrapy spider, which handles the scraping logic and the extraction part. Now, in order to do the same, so what I'll do is I'm going to create a new Python file in this spiders folder. So I'll open this folder, and here I'm going to say new file, and for the file name I'm going to write as bookscraper.py. Okay, I'll create a new blank file over here. Now here, this spider file that I have created just now, this spider file will contain the spider logic and the scraping code. Now in order to determine what needs to go inside this file, so let's go ahead and perform some high level analysis on this website. So if I open this website, so this is how my overall website would look like. Now what I'll do is I'll right click and I'm going to say view page source. Okay, so this is going to display my overall page source. So here under this we've got the HTML tag, and you can clearly observe the various tags that we see right here. See, we have got the tags that we have got right here, and what I'll do is I'll right click and I'm going to say this time I'll say inspect. Okay, now if I go ahead and right click on the inspect, you can get to know how each and every object is present right here. See, under this elements we can clearly see this overall file is an HTML file, and we can actually inspect the individual element that we have got right here. So this is present in the format of an hierarchical structure. Okay, you can just go ahead and do the activity at your end in your free time. Now for the demonstration purpose, I'm going to use my predefined segments that I want to extract from this HTML so that we can extract the data. Okay, so in order to do the same, so I'm going to find all the data fields and the URL locators as per my requirement, and I'll be implementing this spider. Okay, so I'll open up my VS Code and I'll start writing the code over here. Now for this bookscraper.py, so I'll start by mentioning the code like this. I'll write it as from Scrapy dot spiders. I'm going to import crawl spider, and I'm also going to import a rule. Then I'm going to say from Scrapy dot link extractors, I'm going to import my link extractor. So like this, I'm going to go ahead and implement the complete logic. So I'll pause it over here. I'll complete the code and then I'll show you the complete steps. Okay, so I have done the implementation. Now I'll explain as what is being written over here in the code. So here I'm taking care of necessary imports. from CSV, I'm going to import the writer because I want to extract the data and store it inside my CSV file. So in this class book scraper, so this is going to inherit my crawl spider. So what is going to do is this is going to open the website books.toscrape.com. And here this is going to start iterating over the category pages, which is defined right here, which is actually my CSS selector. And then it is going to start iterating over the book pages on all the category pages using the CSS selector. Okay, now once my book is opened, that is once the book page is actually opened, I'm extracting my image URL, I'm extracting my title, I'm extracting the price, URL, and so on. So to help you understand the same, so the expectation is the system is going to go to this website bookstoscrape.com, and once it goes inside this website, it goes inside each and every category that we have got on this bookstoscrape.com, and in each category it will go to each and every book page, and in each book page I'm extracting the information like the image URL, and I'm extracting the title, I'm extracting the price, and along with that I'm also going to extract the UPC, including the overall URL of this page. Okay, so this is what I'm extracting from each and every page as part of this data extraction. Now you can extend this extraction and you can also perform the further activities as well as per your requirement. So for this example, we are just going to extract these things, and the particular implementation is present in the overall code, that is in this function, as well as the rules that I have mentioned right here. Now along with that, I have written an additional function which is called as save to file. Now for this saving the file, the each and every data that I'm getting from the website, I'm just storing inside my variable and I'm writing it for my CSV file. Okay, so that is what is happening in this method that I have written inside the class, and this method will be called for each and every book data that I'm scraping from this books.toscrape.com. Now once the implementation is done, I'm going to save the file and I'm going to start my terminal. So this time I'm going to run the spider. So in order to run the spider, I'll say Scrapy crawl book scraper, and if I press the enter key, it says enable unknown command crawl. Let's do one thing. Let's go inside the folder. I'll say cd book scraper. Now I'm going to run the command, that is scrapy crawl book scraper. Now once I press the enter key, see the crawling has started. So as it is executing, so you can observe that I'm getting the data. That means I'm scraping the data, and in parallel there's a file that is created, that is data.csv file. Okay, so now once this is done, so it says spider has been closed. Okay, and if you just scroll up, so it is saying what is the individual data that it has got. For example, it says this is the URL of the image. Now let's have a check. I'll copy this URL of the image and I'm going to paste it on a website. So this is the image that it has got. The image URL is lab girl. That's the book image that I've got. The price is $40.85 and the URL is this. So this is the URL of this book. So what it means is we have successfully scraped the website and extracted the required data into this CSV file. Now I'll open this CSV file, which is present in my local directory. So I'll open this CSV file, which is present over here. Okay. So this is the CSV file that has been created right now. So what it means is we have successfully extracted the data from the website. Now, all that is left to do is perform the pre-processing on this data set so that we can effectively use it to perform the analysis on the data set. Alright team, so as part of your learning journey in this video, you have seen how to perform the data extraction in a hands-on manner using Scrapy library. Now, in the next video, we are going to get started with NLTK library where you are going to learn how to perform the pre-processing on the data set. So, I'll see you in the next video. In this video, we are going to learn about the NLTK library. As we progress, we will look into the introduction to the NLTK library and the various text pre-processing ability which is shared to us by the NLTK library. So let's get started and let's understand what exactly is this NLTK library. Now this NLTK library is one of the most widely used NLP library. And here this library provides a module for text pre-processing operations like tokenization, stemming, tagging, parsing, and many more. So this NLTK, I can say one of the go-to library next to next to the spaCy library that we have got. Okay, so this is one of the most widely used NLP library, guys. Now, some of the common pre-processing steps that we generally do whenever we are working with the text data is tokenization and the part of speech tagging, stop words removal, stemming, lemmatization, named entity recognition, and word sense disambiguation. So these are the common text pre-processing steps that we perform in natural language processing. Now, the reason that we perform this pre-processing steps in NLP because when we are working with the text data, we have got the data in various format and you have understood in detail in our previous section as the key challenges of NLP. In order to minimize those challenges, we apply these techniques on the text data so that my machines can effectively understand the text data. That is the whole idea behind pre-processing the text data. Now let's start with tokenization. When I say tokenization, it's a process of breaking up my text into smaller chunks that's called as tokens. Here, when we are performing the tokenization, not just we are splitting on the basis of spaces, along with that, we are also considering the part of speech tag, the way it will be used in a particular language, along with the general rules of the language, we will be splitting our entire sentence into individual words. For example, if you look into this scenario, that is the example on the screen, I have got the sentence that says as let's go to New York. So first thing that I have done is I have performed the splitting on the basis of spaces and there are some exceptions. The exception is n.y. So here n.y actually refers to New York, which is a place name. Hence I have kept that as it is. That means we are going to consider the exceptions as part of the language. We are going to separate the suffixes. Then we are going to consider some natural language based exceptions. And as a result of this, we are going to ensure that while splitting my sentence into individual parts, that is tokens, I'll also ensure that my language that is processing, that is also being considered so that we can effectively split the data without losing much of the information. Now, in order to do this kind of analysis and perform the tokenization on the given text data, we have got three types of tokenizers available in NLTK. They are word tokenize, word punct tokenize, and send tokenize. So you are going to learn in detail in the next hands-on session as how do we make use of all these types of tokenizers. All right. Now, when we perform the tokenization, I'm going to get an individual tokens. Sometimes we not only want to analyze the individual tokens, we want to combine multiple tokens so that I will be having the better idea about the context. Now in such scenarios, I'm going to group more than one tokens together and we call it as bigrams, trigrams, and n-grams. When I say bigrams, bigrams are nothing but the tokens of two consecutive words in a sentence. And trigrams is a tokens of three consecutive words in a sentence. And n-grams refers to tokens of any number of consecutive words in a sentence. This will help us to understand the overall context in which the words are being used. To give you an example, suppose if I've got a text that says as Rama went to forest. Now, in this scenario, if I simply perform the tokenization, Rama will be one token, Went will be another token, 2 will be one token, Forest will be another token. Now, this is a scenario of default tokenization, which we generally call it as a unigram. Now, in case of bigram, what we do is we are going to group two tokens together on the basis of order. So, Rama and Went will be one bigram, Went and 2 will be another bigram, 2 Forest will be another bigram. Now, as you can clearly observe, by generating the bigrams, I'm able to capture the information in a much more better way. Instead of using my individual tokens, I'm using two tokens. So I'm saying Rama went to 2 Forest. Now, when I talk about trigrams, it will be Rama went to will be one token and went to Forest will be another token. That will be my trigram. So this is how the concept of bigram, trigram and n-gram would work. N-gram is a general terminology that we use. So as part of your learning journey in this video, you have learned about what exactly is this NLTK library, the common text pre-processing steps that we perform in NLP, and then you have looked into the various tokenizers that we have got in NLP, especially using our NLTK library, and the concept of bigrams, trigrams, and n-grams. So with this understanding, let's go ahead and implement this in a hands-on manner using NLTK library in the Python programming language. So I'll see you in the next video. In this video, we are going to learn how to perform the tokenization in a hands-on manner using NLTK library. So let's get started. I'll start by launching my Google Colab. So here in this Google Colab, I'll start by importing the necessary libraries. So as I mentioned already, the library that we'll be using this time is the NLTK library. In order to work with the same, I'll say import NLTK. So this is going to import the NLTK library. Now, in order to perform the tokenization, first thing that I would require is downloading the package. So in the NLTK library, there's a package called punct. So I'm going to download that package. I'll say nltk.download, and inside the parenthesis, I'll mention the package name as punct. So once I execute this, this will download the necessary package. Now, once this has been downloaded, I can then go ahead and perform the tokenization. I'm going to get an example text like this. Machine learning is is a subset of artificial intelligence. Okay, this is how I have defined the text. So machine learning is a subset of artificial intelligence, and it does with learning from the data without being explicitly programmed. So this is the string data that we have got. Now, in order to generate the tokens, so we can simply say NLTK dot word underscore tokenize. Okay, and inside the parenthesis, we just have to specify the string. Now, once I execute this, this is going to perform the tokenization on my string data, and this has resulted in the individual elements being the elements in this Python list. See, it has splitted my entire string into individual words. So this is what we call it as a tokenization. Now, if I want to generate the bigrams, trigrams, and n-grams, so we can generate it by calling the respective function. So what I'll do is I'm going to store it inside this ML tokens. Okay. Now, once I've generated these tokens, if I want to generate the bigrams and trigrams, I can simply say it like this. I would say NLTK dot bigrams, and inside the parenthesis, I just have to specify my ML underscore tokens. Once I execute this, this is going to generate an object. If I want to look into my bigrams, I just have to convert it into the Python list. So now we can look into the bigram. So machine and learning is A. So the consecutive two tokens has been treated as a bigram, that is my individual item over here. So this is the concept of bigram. Similarly, if I want to generate a trigram, so I just have to say nltk.trigrams, and this will generate a trigrams from the individual token, that is from my unigrams. So as part of your learning journey in this video, you have seen how to perform the tokenization using NLTK library. So with this, we come to the end of this video. Now, as we progress in our next learning journey, that is in this next video, we will learn about the concept of pause tagging and the stop words removal. So we will learn in detail in the next video. In this video, let's talk about the part of speech tagging and the stop words removal. So as we progress in this video, we will look into the pause tagging, that is part of speech tagging for the text data. And we'll also see how we can remove the stop words from the given text data. So we'll do all these things in a hands-on manner with the help of NLTK library. So let's get started. So let's start by understanding what exactly is this part of speech tagging. Now, part of speech tagging is nothing but marking up the word or a text in my given text corpus as corresponding to a particular part of speech tag based on both its definition as well as its context. And that is what we call it as a pause tagging. Now, here in this example, we've got the text like this: I like to read books. Here, if you look into the scenario, the word like is mentioned as verb, read is mentioned as verb, and so on. See, each and every word that we have got over here, this has been assigned with its respective part of speech tag. Okay, so this kind of tagging a given text data is called as part of speech tagging. Now, the reason that we perform this part of speech tagging on a given text data, because by identifying the part of speech tag for each and every word in my given data set, I can easily understand in an effective way about the context in which that particular word is being used. And that is the role of part of speech tagging. And we have got stop words. Now, stop words are the words which are commonly used in the language. The examples of stop words are a, the, is, are. These are all the examples of stop words. Now, while working with the text data, as you can clearly see, these stop words do not add any important information. Hence, what is the practice that we do is when we are doing the pre-processing, we are going to eliminate these stop words. Now that you have the understanding about this part of speech tagging and the stop words, let's go ahead and implement it in a hands-on manner so that we'll become comfortable in identifying the part of speech tag for a given text data and how to remove the stop words from the given text data. So let's get started. Here I'm using the same notebook that we have used for tokenization that we have used in the last session. So in the same notebook, I'm going to perform the part of speech tagging. Now this time, in order to implement this part of speech tagging, so here we need to download a package that's called as average perceptron tagger. So NLTK dot download, that's the package that I'll download, averaged perceptron tagger. That's the package that I'm going to download. Now, once this package has been downloaded, for each and every tokens that we have generated in the last video, so for each of those token, I'm going to generate the part of speech tag. So for token in ml underscore tokens, I'm going to say print NLTK dot pause underscore tag, and inside the parenthesis, I'll just pass the value of my token. So once I execute this, see, this has resulted in a output that look like this. It says what is the composition of individual word. It says word machine belongs to NN, which is nothing but the noun. We've got verb, so determiner. So in this way, we can assign the part of speech tag for each and every word that we have got in this token. So NN refers to the noun singular. If I have any something as MD refers to the modal. VB refers to the verb base form, and VBN refers to the verb part. Principle, past principle, we have got IN which refers to a preposition, DT refers to determiner. So like this, we are going to assign the various part of speech tag for my individual tokens. Now, one thing that you have to remember is whenever we are generating the part of speech tag for a given text data, so This part of speech tag, that is pause tag function, is unable to differentiate between a noun and a verb because of the use of the inappropriate tokenizer. So that's one thing that you have to remember to help you understand the same. I'm going to mention like this. I'll say a sentence is equal to Jerry eats a banana. Okay. Now what I'll do is I'm going to apply the tokenization. I'll say tokens is equal to NLTK dot word underscore tokenize, and inside the parenthesis I'll specify the sentence that I have defined earlier. Now for each token in tokens, I'm going to say print NLTK dot pause tag, and I'll mention the value as token. So if I execute this, so the output will be able to observe something like this. For Jerry, it is mentioned as NN. Okay, and the eats is considered as NNS. Okay, so what it has considered is this tagger has considered both Jerry and eats as a single term, and it has tagged it as a noun. Okay, so this is one of the shortcoming whenever we are making use of pause tag from the NLTK library. So generally what we do is in the real-time implementation, we make use of pause tags, which is little advanced, especially from spaCy library or from the transformers. So that's the overall idea that we do it as we proceed in the real-time implementation, which even you'll be learning as we progress in the further videos of this course. Okay, now moving on. So next thing that I'm going to show you is about the regular expression tokenizer. So we can also tokenize the text using the regular expression tokenizer. In order to implement the same, first I'm going to import it like this from NLTK dot tokenize, and I'll import regular expression tokenizer. Now, once I import this regular expression tokenizer, I have to initialize my regular expression tokenizer. So I'll write it like this: regular tokenizer is equal to regular expression tokenizer, and I'll mention some data over here. Now, in this example, so I have initialized the regular expression tokenizer, and then once I have mentioned the regular expression inside this regular expression tokenizer, in order to tokenize it, I just have to send in my text data inside this tokenize method, and I have generated the pause tag. So this is another way to apply the tokenizer. All right, and then we have looked into the concept of stop words. So in order to apply the stop words, so what we will do is generally we are going to download the stop words. Okay, once I download the stop words, I'll check if my any words in my sentence is belonging to my stop words, then I'm going to exclude it. To show you the same, I'll say from NLTK dot corpus, I will be importing my stop words. Then in order to display the stop words, I'll write it like this: stop words is equal to stop words dot words, and I'll mention my English language. Okay, now if I display my stop words, okay, so this will display the stop words. Currently it is asking me to download a package that is stop words, so let's go ahead and do that as well. So see, this has displayed the list of stop words that is present over here as part of this NLTK library. Now what I can do is I can now perform the filtering. So the way that I can apply the logic is I'll say filtered data is equal to, I'm going to say for w in ml underscore tokens if not w in stop underscore words. So if it is not present in stop words, then only get the value as w. Then if I now display this filter data, so we now have the data. after we have removed the stop words. So here it says machine learning subset artificial intelligence learning data explicit without explicitly programmed. So that means we have removed the stop words. If you look into our original data, that is ml underscore tokens, see, we have got the words like is, a, of. So all these stop words has been removed. See, all these stop words has been removed from this stop words removal process. So as part of this video, you have learned as how to perform the part of speech tagging and also how to remove the stop words. As we progress in the next video, we'll look into the concept of stemming and lemmatization. So I'll see you next time. Now in this video, we are going to learn about the stemming and the lemmatization whenever we are working with the natural language data. So as we progress in this video, we'll look into the concept of stemming, lemmatization, and we'll also perform the hands-on activity where we are going to see how to execute this task of stemming and lemmatization on a text data. So let's get started, and let's start by asking a basic question. What exactly is this stemming? Now, stemming is the process of removing a part of word or reducing a word to its stem or a root form. So the other definition where you would see many research paper would talk about is, so I can say this stemming as a technique which is going to lower the inflection that is present in the word. It will perform the lowering activity of my inflection of the words, and it will lower the inflection into their root form. So as a result of this, this will be a pre-processing activity that will be performing on the text data. Now you might be wondering, what exactly is this inflection? Now this inflection is a process through which the word that we have got is modified in order to communicate many grammatical categories. It would include the tenses, it would include the voices, it would include the aspect, person, number, gender, and mood. So all these things will be added in order to communicate to the other person. So even though I may have a word which is present in several inflected forms, now, if I use all those inflected forms inside the same text, this is going to cause the issue of redundancy into my natural language processing task. So as a result of this, we are going to employ this activity of stemming so that we are going to reduce the number of words that we have to process whenever we are applying the machine learning models. Okay, to give you an example, so the stemmed version will be generous itself. Generously, the stemmed version is generous. And generate, the stemmed version is generate, and generation, the stemmed version is generate. Now with this example, so here the generate, the word that you see right here, the one that I'm highlighting, you can clearly see that this is the stemmed version of the word generation and generate. And this generate is not a word that is present in a dictionary. So this is not a recognizable word. So I can say that whenever we apply the stemming on a given data set, at that time, that particular word might not be a recognized word. Now, the reason that I'll be performing this stemming is, so if I have various variances in my overall text corpus, this would result in data redundancy. So in order to reduce those data redundancy whenever we are applying the machine learning models, so in that scenario, we apply this activity of stemming so that we will have an effective model building. So this stemming is used in variety of application. So this is used in text mining, search engine optimization, web search. It is used in indexing, tagging. In all those scenarios, we make use of the stemming. Now working with NLTK library, there are various types of stemming algorithms that we have got. First one is Porter stemmer. So this algorithm was actually invented by the Porter. Okay, the name of the person who invented is Martin Porter in the year of 1980. So here we make use of this Porter stemmer, which is a module that is present in this NLTK library, which will actually apply this Porter technique.
So here, this Porter stemmer is a original stemmer, and this is one of the renowned for its ease of use and the rapidity. So frequently, the resultant stem is shorter word with the same root meaning. That's the overall idea behind this Porter stemmer. And apart from that, we've got the snowball stemmer. So this was also created by the same author, Martin Porter. So this method utilizes more precise and is referred to as an English stemmer or a Porter 2 stemmer. So this is much more faster and more logical than the original Porter stemmer. So here, when we are working with this NLTK library, we've got a module called snowball stemmer, which will implement this snowball stemming technique. Okay, then we have got the Lancaster stemmer. So this is a straightforward, and this produces with excessive stemming, over stemming sometimes. That is what we call it when we are applying this Lancaster stemmer. So sometimes we would observe that the stems that we get from this Lancaster stemmer are non-linguistic or meaningless. So in order to implement this in NLTK, we have got a Lancaster stemmer module which we can use it to apply this Lancaster stemming technique. And then we have got regular expression stemmer. So regex stemmer identifies the morphological affixes using the regular expression. So the substrings which are matching the regular expressions will be discarded. And in order to apply this regular expression stemmer, we have got regexp stemmer, which is a module in NLTK, and this is going to implement the regex stemming technique. So these are the 4 types of stemming that are available in NLTK library. Moving on, we have another pre-processing activity that we perform on the text data that's called as lemmatization. Now here, lemmatization is a process of grouping the words together and the different inflected words of a word so that they can be analyzed as a single word. Here, this is going to convert the words into its root word using the part of speech tag as well as its context as a base. So this is very similar to stemming, but this is bringing the context to the words. So the resulting stemmed word or resulting root word that we get from this lemmatization process will be a valid word in a dictionary. And this lemmatization has variety of applications. It is used in comprehensive retrieval system like the search engine, and it is used in the compact indexing. In this example, the word eats, ate, and eating. The lemmatized version of that word is eat. Okay, so the difference between the lemmatization and the stemming is, in case of stemming, the root word might not be a meaningful word in the dictionary, but the root word from the lemmatization process will be a meaningful word in the dictionary. And here, in case of lemmatization, we are going to generate the root word by considering the context. So this is the overall idea behind the stemming and the lemmatization. Now let's go ahead and let's implement the stemming and lemmatization in a hands-on manner using the NLTK library. I'll come back to my Google Colab and I'll start by importing the same. So the first stemming that I'll be applying right now is this Porter stemmer. So let's go ahead and implement the same. I'll write it like this. I'm going to say from NLTK dot stem, I'm going to import Porter stemmer. Okay, and in order to work with this Porter stemmer, I'm going to say like this: Porter is equal to, so Porter is equal to Porter stemmer. So I'll create an object for Porter stemming. Now here, once I create this Porter stemmer object, I'm going to get some example words for the like checking purpose. I'm going to say words is equal to generous, generate, okay, and I'll mention another word as generously, along with that generation. Okay, these are the individual words that I have got over here. Next, in order to get its root word, I'm going to write it like this:
For word in words, I'm going to say print. Okay, so I'll mention my word. Okay, I'll display this word and I'll add a symbol over here, and I'm also going to generate the output of this porter stemming. So porter dot stem, and I'll apply it on the word. So if I execute this, this is going to generate the outcome of applying this porter stemmer. Generous, generate, generously, and generation. Its stemmed version is gener itself. So this is the output of this porter stemmer. Okay. Now, apart from this, we have looked into a case of snowball stemmer. So let's use the same set of words, and this time let's apply the snowball stemmer. So instead of porter stemmer, this time I'm going to call this snowball stemmer, and I'll create an object for this snowball stemmer, and I'll mention the language as English, and then I'm going to call this as snowball. So snowball.stem word. So if I execute this, see, this is how the overall output would look like as a result of applying the snowball stemmer. Generous has been changed to generous. Generate has been changed to generate. Generously is genor. Generation has been changed to generate. So this is the output of this snowball stemming. Similarly, if we apply the Lancaster stemmer, so Lancaster stemmer, and I'm going to apply this Lancaster stemmer, and I don't have to mention the language for this Lancaster stemmer, and I'll specify the object name as lan. Okay, and I'm going to apply the stemming on those words. So see, this is the output of this Lancaster stemmer. And one thing it is pretty much clear is when we talk about this Lancaster stemmer, so we can clearly observe that this is going to do some kind of an excessive stemming. That's what we clearly observe in this example when we apply this Lancaster stemmer. Okay, now we also have the regular expression stemmer, so we can also apply that by specifying the regular expression. Okay, so these are all the various types of stemmer that we have got. Now let me show you the regex stemmer as well. Okay, we'll initialize this regular expression stemmer, and I can specify some regular expression. So for the example purpose, I'm going to write it like this: ing yes. Okay, I'll just mention something like this. Okay, and I'll say min is equal to 4. So I'll be initializing my regular expression stemmer. So I'll take these words and I'm going to apply the stemming on those words. So here what we have done is we have actually applied the stemming on the basis of the regular expression. See, what we have done is I have mentioned that if you observe yes, so just remove it. So here in this scenario, I've got yes over here at the end. As a result of this, so this yes character or the matching character, matching substring has been discarded when I apply this regular expression stemmer. So this is the overall working of this regular expression stemmer. Okay, now apart from the stemming, we have also learned about the concept of lemmatization. So lemmatization will help me to get the base form of the word, but the output that I get will be based on the context in which that the word is being used, and also that will be a valid word in the dictionary. In order to apply this lemmatization, I'm going to say from NLTK dot stem, I'm going to import word net lemmat. Okay, now once I import the same, so I'm going to say lemma is equal to word. Okay, now next I'm going to write something like this. I'll copy this and I'll paste it over here. I'll say lemma dot lemmatize. Now once I execute this, so currently it is asking me to download a package, so I'll download the same. Okay. Now, if you look at the output, we have got the lemmatized version of the data. Generous has been changed to generous, generate has been changed to generate, generously, generously, generation, generation. So it has helped me to get the data in its base form by considering its context in which the word is being used. So this is the overall idea behind this lemmatization. Okay, so as with this, we come to the end of this video. Now, as we progress in the upcoming video, we are looking to the concept of NER and word sense disambiguation in Python programming language. So let's learn about the same in the next video. In this video, we are going to learn about the concept of named entity recognition and word sense disambiguation. As we progress, we will look into its understanding of these two important concepts and its relevance in natural language processing, and we'll also implement it in a hands-on manner using Python programming language. So let's get started, and let's start by understanding what exactly is this named entity recognition. So this named entity recognition is a first step that we perform towards the information extraction. That means extracting the important information from the data set, that is the text data. Here, in the scenario of named entity recognition, we seek to locate and classify the named entities into the predefined categories like the names of a person, organization, and the location. Okay, so that's the core of this named entity recognition. Some of the categories that we generally do is person, organization, location. Sometimes we also call it as a place. Apart from that, we will be looking into the other important things as per our requirement. Okay, now moving on. The other challenge that we have got whenever we are working with the natural language, that is a human language, is that one word can have multiple meanings depending on its usage. Understanding the various usage patterns in the language is very important for the various natural language processing applications. Here, when I say word sense disambiguation is a method by which the meaning of the word is determined from the context in which it is being used. The reason this is very important because in various usage situations, the same word can mean differently. Now, if I want to give you an example, let's say bark. That's a word that I'm going to take it as an example. Here, the bark refers to the outer covering of the tree, and also the other meaning would refer to the sound made by the dog. To give you an example, cinnamon comes from the bark of the cinnamon tree. The dog barked at the stranger. Now here, in both of the sentences, the word bark has different meanings. See, we have got the same word used, but it has got different meanings. Now, if I want to pass these two sentences into an algorithm, then at that time, if I want my computer to differentiate these two sentences, then that is the challenge lies in the NLP. That's where the word sense disambiguation comes into picture. Here, it's an important method of NLP. In this scenario, the meaning of the word is determined, which is used in a particular context. So this word sense disambiguation basically solves the ambiguity that rises in determining the meaning of the same word, which are used in various situations. So I can say that this WSD, that is word sense disambiguation, has its variety of application. It can be used in text mining, information extraction, it can be used alongside with lexicography. So it is used in information retrieval process. So it is used in various applications. Now, here, in order to implement this word sense disambiguation, there are a variety of ways. One method is supervised method, semi-supervised method, unsupervised method, but most importantly, one of the commonly used method in natural language processing is the LESC algorithm. So this LESC algorithm is a classical word sense disambiguation algorithm, and this has been introduced by Michael E. Lesk in the year of 1986.
So this algorithm is based on the idea that the words in a given region of the text will have the similar meaning. Here in the simplified LESC algorithm, in this overall simplified LESC algorithm, the correct meaning of each word context is actually found by getting the sense which overlaps the most among the given context and its dictionary meaning. That's the overall idea about this LESC algorithm. Now, given the importance, let's go ahead and let's see how we can implement the LESC algorithm with the help of an NLTK library by writing the code in Python programming language. For that, I'll go back to my Google Colab. Here, I've already written the code which implements the LESC algorithm. Here I have implemented this LESC by starting the importing the same. So from nltk.wst I have imported LESC, and from nltk.tokenize import word tokenize. Now once it is imported, here I have mentioned some example. So I have mentioned as A1, which is first algorithm where I'm applying the LESC algorithm after I perform the word tokenization on the sentence. The sentence here says the building has a device to jam the signal. Here I'm getting the information about the word jam, and once I have applied this algorithm, I have said as print a1 comma a1 dot definition. Okay, then I have mentioned as a2 and I am applying the LESC algorithm on the sentence which says as I'm stuck in a traffic jam. Now in both the sentences I've got the common word, that is jam. Now once I apply this LESC algorithm, let's have a look into the meaning of these individual words. That means we are trying to understand the context of these two individual words once I apply this LESC algorithm. Here, the first output says deliberate radiation or reflection of electromagnetic energy for the purpose of disrupting the enemy use of electronic devices or the system. And for the second one, the second meaning here, it says get stuck and immobilized, which implies the traffic jam. Which means here in both the sentences, the meaning of the word has been perceived in a correct manner by applying this LESC algorithm. Isn't this amazing, guys? Great. Now moving on, let's go ahead and let's apply it on another example. Here for the other example, I have mentioned as A1 is equal to LESC. I'm performing the tokenization. Here this time I'm making use of this word tokenize, and I'm mentioning the text as what is the current time. Next, on the second sentence, I have mentioned as air current. So in the both the scenarios, I'm trying to get the meaning of the word current, and if I execute this, so it says in the first sentence, the word current would mean occurring in or belonging to the present time, which is exactly correct. And the second sentence here, the meaning says dominant core suggestive of running water, of successive events or ideas. Clearly, both have been identified correctly. So what you have seen just now is how easy it is to find the meaning of the words by making use of LESC algorithm. In order to implement this, ensure that you apply the tokenization. Post that, you'll be able to apply this LESC algorithm. Now, apart from that, we have looked into the concept of named entity recognition. In order to apply this named entity recognition, here I'm just downloading two packages, Max and AnyChunker, and the words. Okay, once I have downloaded the same, here let's do one thing. Let's define an example text data. My example text here says Apple is an American company based out of California. Now, in order to get the named entity recognition from the given string data, I have to apply the tokenization. On top of that, I have to get its relevant part of speech tag. Now, with the usage of its relevant part of speech tag as well as its token, I can then extract the named entity recognition. So here in this example, I'm saying that nltk.word tokenize w. So for each of the word that is present in this word tokenization, okay, so what I'm doing right now is I'm going to apply the part of speech tag. Then on top of this, I'm going to
apply the any underscore chunk, and this will help me to get the named entity recognition. So if I have any label associated with that word, I'm just going to print the same. So if I execute this, it says the apple has been identified as GPE, American has been identified as GPE, that is geopolitical entity, and California has been identified as geopolitical entity. So what it has done is it has clearly identified and extracted the important tokens and its usage in a given string data. So this is what we call it as named entity extraction for a string data. Now you can try out with various examples as well. So this time I'm going to write it like this. I'll say is the Prime Minister of India. And if I execute this, see, Narendra has been identified as geopolitical entity, Modi has been identified as geopolitical entity, and India has been identified as geopolitical entity. It means, so even though it's not 100% correct, so we can still use it, but we have to be very careful if we are working on a sensitive data. We don't want to tag it to the incorrect labels. So in such scenarios, ensure that you train the data, that is you train the model with the help of supervised learning, and then you can further use those labels for the future purpose. All right, folks. So with this, we come to the end of this video. As we progress in the next video, we are going to learn about the spaCy library and how we can work with the spaCy library. So I'll see you in the next video. Hey everyone, in this video, let's have an introduction to spaCy library. So as we progress, we will understand what is spaCy, the key features of spaCy, and I'll also show you as how you can get started by working with the spaCy library. So let's start with the basic question. What is the spaCy? So spaCy is a free open source library for advanced natural language processing in Python programming language. And one key thing that you have to remember when I talk about this spaCy is spaCy is designed specifically for production use. So this has resulted in a greater advantage compared to the NLTK library. So NLTK library was basically created for research purpose, but spaCy is designed specifically for production use. And with spaCy, it will help you to build the application which will process and understand the large volumes of the text data. So that is the importance of spaCy library. Here, when we talk about the spaCy library, it has got some of the rich features. If I want to describe one by one, so spaCy has the feature of tokenization. So tokenization, as you know, it's about segmenting my text corpus into the individual words, punctuation marks, and so on. So it will help me to split my text into multiple words. And this has got the feature of part of speech tagging. That means this will help me to assigning the word types to my tokens like verb, noun, pronoun, and so on. And this has got the dependency parsing. So when I say dependency parsing, it's about assigning the syntactic dependency labels describing the relationship between my individual tokens like the subject or the object. And spaCy has an ability for lemmatization as well. As you know already, lemmatization is nothing but getting the base form of the word or the root form of the word. So this will help me to get the lemmatized version of my individual tokens. And we have got the sentence boundary detection. So it will help me to segment my individual sentences in my paragraph. And we have got the named entity recognition, which is nothing but labeling the named real world objects like persons, companies, and location for my text corpus. And we have got the entity linking feature, which is nothing but disambiguating the textual entities to unique identifiers which are present in my knowledge base. And this has the ability to perform the activity of similarity, where we can compare the words, text spans, and the documents and measure how similar they are to each other. And the great feature that we have got in this spaCy is text classification, where we can assign categories or labels to my entire document or parts of the document. We have got rule-based matching. So here in the scenario of rule-based matching, it's all about finding the sequences of tokens based on their text and the linguistic annotations. And this is similar to the regular expression. And this has the ability to train the models, so we can update and improve the statistical models prediction as well. And this spaCy supports serialization as well, which means we can save the object to files or the byte string. So these are all some of the amazing features of spaCy, which makes it a number 1 choice whenever we are working on the production grade applications, especially with natural language processing tasks. Now that you have understood the importance and the benefits of using this spaCy library, let's have a look into an understanding as how we can get started with spaCy. See, in order to get started with spaCy library, we'll start with the basic import. We'll say import spaCy, and then in order to load a model, we will simply say spaCy.load and mention the model name. Now once that is done, here, if I send in any text data in this scenario, I have created an NLP object, which is nothing but loading the model from the spaCy. Then for this NLP object, once I send my text data, here in this example, I have mentioned as Apple is looking at buying the UK startup for 1 billion. So that's it. So I just have to apply this text data on this NLP object, and that will help me to get all the other properties as an output from this NLP object. So we'll discuss in detail as we progress in the next video. All right. So the easier way to get started with spaCy is install the spaCy library and load the language model and send in the string data into the NLP object. So with this, we come to the end of this video. As part of your learning journey in this video, you have learned about what is this spaCy, the key features of spaCy, and how to get started with spaCy library. In the next video, we are going to learn how to work with this spaCy library in a hands-on manner. So I'll see you in the next video. Welcome back to your learning journey in this natural language processing. In this video, let's go ahead and let's work with the spaCy library in a hands-on manner. So let's get started. I'll open my Google Colab. So let's start coding over here. So here, as we have studied in our last video, so spaCy is a library which has been designed for the production use. So in order to work with this spaCy library, we have to install it. So since I'm using the Google Colab, this comes with spaCy pre-installed. If you do not have it, ensure that you run the command pip install spaCy. So this is going to install the spaCy library in your local system. So here it says requirement already exists, which means the spaCy library comes as pre-installed for me when we are working with this Google Colab interface. Now, once we have validated whether this spaCy library is available to us, I'll start by importing my spaCy. Now, while working with the spaCy, as we have seen in our last session, so to get started, we are going to create an NLP object. So I'm going to write it like this: NLP is equal to spaCy dot load, and inside the parenthesis, I'm going to mention the version of the model that I'm going to have. So I'm going to say ENSM. So this is one of the version that is available inside this spaCy library. Now, apart from this, we have got the another version that is called as medium, which is given by MD. Okay. And then there is also a larger version as well. Like, it all depends on the pre-trained model that I want to load. Okay. That is the language. So for now, I'm going to load this English small model, that is the English small model language model, in order to get started. So this is going to load the English small model for us. Now, in order to work with the same, I'll start by defining an example text data. So I'll get a review text. I'm going to mention it like this. Okay, I'm going to mention a review text which would look like this. So this is one of the texts that have got, so especially a famous known for the text classification. It says this is one of the greatest films ever made, and you can just go through the same. So it just talks about some text data which I've collected. So you can definitely check out for the same for more information. So I'll just show you to you. Okay, so this is the overall text data that I have got with me. So on this text data, we'll go ahead and instantiate this document text. So I'll write it like this. I'll say doc is equal to NLP and I'll apply this text. Okay. Now, once this is done, so here, if I simply list down as dir and doc, so you'll be able to see the various outcomes that we have got right here. We've got bytes, we've got class. So we've got a lot of things that are available inside this document object right now. Now, what has happened is, so I have created a text and I have read that text into my spaCy. That is by sending the text into my NLP object. So at this time, we are applying the pipeline of NLP processes to this given text. By default, the spaCy library applies the tagger, parser, as well as NER, that is named entity recognition. So these are the default things that will be applied on the text data. Now, if required, we can also add or replace or remove any of these steps. So remember, removing the unnecessary steps for a given NLP, so it can substantially lead to like decreasing in the processing time. So ensure that you remove it if it's definitely not required. See, when I apply a text data on the NLP, so it will automatically apply all these things. So the first thing that you see right here when I send the data to this NLP object is the tokenizer. Now, when I say tokenizer, so this tokenizer which is present inside my spaCy, it is going to tokenize the text. That means it will segment it into individual words. Here, once it segments, okay, so it will then go ahead and apply all these techniques. Now, whenever it is performing the tokenization, so it is going to apply some rules on the basis of that specific language. For example, it will look into the punctuation at the end of the sentence. So it would say that, okay, punctuation at the end of the sentence should be split off. And when I say n dot y, it should remain as one token. So it will apply some rules and it will take some account of exceptions. It will consider the suffixes, prefixes. It considers everything and then it is going to generate the output for us. Okay, that is the overall idea behind the working behind this tokenization. Now, as I've mentioned, if I want to apply the tokenization on a text data, so what I can do is I can just send the text into my NLP and this will help me to generate the tokens. Now, since it is applying the NER and other things automatically, it will be a best if we go ahead and display each and everything that we have got. So I'm going to mention something like this. For the easier working, I'll just define an example text data like this. Okay, this is one of the greatest movie. I'm just going to have a shorter text so that we can visualize the output. So this is the text data that I have got. Okay, now on this text data, I'm going to apply the NLP. Next, what I'll do is I'm going to mention like this. I'll say for token in doc. Okay, I'm going to display the output like this. So I'll just display the output in a correct formatted way so that we can visualize the data in an effective manner. So, all right, now once I execute this, so here this has given me the output in the required format. So what it means, let me just mention my column headers as well. So I'll just mention my column headers. Perfect. So that text is my first column. This is the lemmatized version, part of speech, tag, and dependency parser. shape, ease alpha, and ease stop. So this is what we can actually get as an output. So these are the important ones that I have considered. So the way that we read it is this. So the word is this, its lemmatized version is THIS, this itself, and the part of speech is pronoun. And the tag it has assigned is determiner. And here it says for the dependency parser, it has mentioned as en subject. Now let's say you're not sure as what each of these terms would mean. In such scenarios, what you can do is you can make use of spaCy's explain function and send in the one which you want to understand the value. Let's say n sub j, and if you execute this, it says it's a nominal subject. Okay, so in this way, you can get the meaning of the terms that is being used by the spaCy library. And here we have got as aux. So let's just understand the meaning of aux. So here the aux would mean it's an auxiliary term. So in this way, we can get to know about our individual tokens, its lemmatized version, its part of speech, tag, dependency parser, and it also says how is this the shape. That means whether it is in camel case. So here the x in bigger X, it refers to our uppercase, and the smaller x refers to our lowercase values. Okay, ease alpha means whether it contains the alphabet. E-stop means whether the data that we have got, whether it is a stop word or not. So all these things, we are getting it as a single output. We did not apply separate function over here. When I just send the data to my NLP, so at that time, we will get this as an output by default. Okay, now using this part of speech, I can then go ahead and perform the extraction as per my requirement. So I can write a logic which says that if my adjective is followed by the noun, only at that time go ahead and give me the output. So to help you understand the same, maybe I can write a logic which looks something like this. Here I've mentioned as previous token is equal to doc0. That means I'm going to get my first token, and I'll go through the every other token that I have got over here. So I'm checking as if my previous token is adjective and my current token is noun. That means if my adjective is followed by a noun, then I'm interested in printing the output. Now once that is done, I'm going to set my current token as my previous token and I'll proceed with the iteration. So the words that are matching this condition are greatest and movie. So in this way, we can make use of the part of speech tag which are assigned to our individual tokens and apply that as a filter to extract the important information from my given text data. Okay. Now, if required, we can also extract the entities as well. So if I want to extract the entities, I'll just specify this text condition like this. Okay, so what I'll do is for the example code, I'm going to write it like this. Okay, I'm going to write it as my ner text is equal to I love my country, India, and I love machine learning. Okay, let's say this is my text data that I have got with me. Now on this text data, I'm going to apply the NLP object. I'll say ner doc is equal to NLP ner text. Okay. Now once this is done, so I can just apply this ner text, that is the text I have considered. Now here, if I want to describe the entities, so I can directly mention the entities right here. I'm saying that ner dot entities, and if I execute this, so it is going to tell me what is the label and what is the entity. So for the India, it has been identified as GPE. For machine, it has been identified as a product. Okay, so in this way, we can also perform the named entity recognition as well. Now, if I want to display this in the format of a formatted text, then in spaCy, we have got a function that's called as displaycy. In order to use the same, I'll say from spaCy import displacy, and I'll say displacy dot render, and I'm going to mention my doc is equal to underscore doc, and I'll say style is equal to entities, and this is followed by Jupyter is equal to true. So if I execute this, so this is going to generate me the output. So it says allow my country India, just geopolitical entity, and I allow machine learning. So here machine has been identified as a product. Okay, now if you want to understand what exactly is this GPU would mean, so you can simply make use of spaCy.explain function, send that as an input, get the answer. GPA refers to geopolitical entity, that is countries, cities, and states. Okay. Now, in the spaCy, we also have the ability for detecting the sentence boundary as well. So we can do that and we can start working on our data set. All right, folks. So what we have done as part of our learning journey in this video is we have seen how to get started using this spaCy library and how easy it is to work with this spaCy library. In order to work with this spaCy library, we will import the same by specifying as import spaCy. We will initialize the NLP object by mentioning the language model that we want to use, and we directly apply the text data. Once we apply the text data, it passes through the tokenization, followed by the other parsing like tagger, parser, ner, and so on, and it will apply it on our text data automatically. And this is called as NLP pipeline in spaCy. Then we can access the individual properties by calling its respective attributes. So this is the overall idea behind usage of spaCy library for natural language processing. So with this, we come to the end of this section. In the next video, we'll look into the summary of this section, which will help you to quickly summarize the learnings that you had in this section and prepare you for the next section. So I'll see you in the next video. In this video, let's quickly summarize the learnings that we had from this section. See, as part of your learning journey in this section, you have understood what are the components of a pipeline in natural language processing. And more importantly, you have looked into the various ways to pre-process the text data. Now, the reason that we apply the pre-processing on the text data because it will help us in reducing the number of feature words in my data set, which in turn helps me to improve the overall accuracy of my machine learning model. So as a result of this, this will help me to represent these text data in a numerical format in a much better way, which we will be studying in the next section. So as we progress in our upcoming video journey, we will get started with the new section that is about how we can convert this text data into a numerical format. And that's what we'll be learning from the next video, that is text vectorization. So I'll see you in the next video. Hello everyone, welcome back to your learning journey in this natural language processing. Now in this video, we are going to learn about the text vectorization technique, a technique which we use it to represent the raw text in a numerical format. So as we proceed in this video, we will understand why do we require a text vectorization, and we'll also understand about the concepts like one-hot encoding and how to implement this one-hot encoding in a hands-on manner. And at the end, we'll also look into the disadvantages of this one-hot encoding technique. So let's get started. Now, when we talk about this text vectorization, it's a technique that we use it to convert the raw text into a numerical format. So this technique is also known as feature extraction. Sometimes we refer it as text representation as well. It's all about converting the raw text into a numerical format. Now, the reason that we do this activity of converting the raw text into a numerical format, because when we talk about the machine learning model, it expects the data in a numerical format. If I have the text data in a numerical format, then only I'll be able to apply it on the data set and find the patterns for a given data set. Now you already know the importance of data set. So no matter how good my machine learning model will be, if my data set is not correct, then in such scenarios, it's like sending the garbage in. So when I send the garbage in, I'll get the garbage out, which means if my data itself is not proper, then the accuracy of my machine learning model will be very low.
Hence, it is recommended that we work with the data in a much more efficient way so that the machine learning model can learn the patterns in the present data set in a much more better way. That's the overall idea when we talk about this feature extraction. Here, under this feature extraction, so we've got various methods like which will help us to convert the data into a numerical format. We've got one hot encoding method, we've got count vectorizer method, we've got TF-IDF method, and we also have the word embeddings method. So these are the various methods that we have got to represent our text data in a numerical format. So let's understand what is this one hot encoding technique. Now, when I say one hot encoding technique, it's a technique where every word, including the symbols which are part of a given text corpus, are written in the format of vectors. And this vector will have only ones and zeros. Now, in this one hot encoding technique, each word that we will have, so each word is written or encoded as a one hot vector, with each one hot vector being a unique one. Now, in this scenario, remember that no two words will have the same one hot vector representation. Now, to help you understand this one hot encoding technique, so consider the data that you see here on the screen. So I've got the column called color, and in this column of color, I've got three unique values. The three unique values are red, yellow, and green. So these are the three unique values that I've got in this column. So what I'll do is I'm going to create a matrix, and in this matrix, my each and every column will be the unique value that I've got in that column. So red, yellow, and green, which are the three unique values from the column of color. Now, once I have the data represented in this way, that is in the matrix format, to convert my text data into a numerical format, so I'm going to represent it in the format of a vector where for each and every matching value, I'll mention as 1. For example, for the color as red, so under the red, I'll mention as 1. Rest everywhere, I'll mention as 0. So in the second row, it is red. So 1, 0, 0. In the third row, I'll have as 1, and rest other places, it will be zeros. And in the here, it says green. So under green, I'll have as 1, rest 0. So this kind of representation is called as one hot representation for a text data or a string data. Now, even while working on the text format as well, we will be converting this text data into a numerical format. Now, let me help you to understand as how do we actually represent the text data in the format of one hot encoding. For that, I'll take up an example. Let's say I've got a sentence one which says as dog eats meat. Okay. Next, I've got man eats meat. So I've got two sentences, sentence 1 and sentence 2. Now, just like I'm going to get the unique values that I've got in my column, in case of NLP, I'm going to extract the unique words that are present in this vocabulary. The unique words are dog eats meat and man. So these are the four unique words that I've got in my given text corpus. Dog eats meat and man. So the total unique number of elements are 4. So just like we have done last time. So I'm going to say dog eats meat man. Okay. I'm going to keep it as a columns and I'll construct a matrix like this. Now, if I want to represent the word dog, 1 eats 0, 1, 0, 0. Meat, it is 0, 0, 1, 0. And in the same way, man is 0, 0, 1. So you can clearly observe that when I have the one hot representation of my individual words, no two words are having the same one hot vector representation. Each word has a unique one hot encoder representation. Okay, so that is one important feature that you have to remember. Now, once I have represented this text data in this one hot representation format, that is each tokens or words in a one hot representation format. If I now represent my sentence one, so sentence one is dog, so 1, 0, 0, 0.
meat is does 10. So this is the representation of my sentence 1. So here I have represented my sentence 1 with the help of one hot vector. In this way, we represent the given text data in a one hot representation format. Now that you have understood as how we do this one hot encoding for a given text corpus, let's go ahead and implement the same in a hands-on manner. For that, I'll open up my Google Colab and let's have a look into the code. So here in this scenario, I've got the text corpus which says as dog eats meat and man eats meat. Now, just like we have extracted the values over there, the unique words, I'm going to build the vocabulary in this scenario as well. And along with building the vocabulary, I'm going to specify the integer value just for the labeling purpose. So I've assigned the label as 1 for dog, 2 for eat, 3 for meat, 4 for man. Now with these integer values, I'm going to represent the one hot representation. Here I've defined a blank Python list. Okay, so this is my blank Python list. Now on this blank Python list, next I'm going to create it where this Python list is filled with zeros. Now let me give you an example. What I'm doing right now, I'm saying as 0 multiplied by 4. I'm just giving you an example. So this is going to build a Python list with every value filled with zeros. Next, let's suppose I want to fill this value. Okay, value at the value of the dog, that is the 1, which has got the index value 1. Now I'll show you as how it is written. I'll say L1 is equal to 0 into 4, right? Now if I print my L1, this is how it would look like. Now I want to represent the dog at the first index position. But in Python, you know that the indexing starts with 0. So that means if I want to access this element, this is the element at the index position 0. So what I can do is I can say L1 0 equal to 1. Now after that, if I print my L1, see, I have got the one hot representation for the word dog. So I had a 1 over here. So what I did, I deducted 1 from this integer value that I have got, because the indexing starts from 0 in case of Python list. Okay, so we have implemented this strategy and we have written the code like this. So I've created a Python list filled with zeros equal to the length of my vocabulary, that is 4. Then I'm going to check if my word is present in vocabulary. If it is not present, then in such scenarios, I'm going to just ensure that. So I'll just get its index position -1. And after that, I'm going to append it back into my one hot. That means I'll get the one hot representation for my individual elements and I'll place it into my final Python list, that is one hot. So if I execute this by sending in an example text data, dog eats meat, see, I've got the one hot representation of my individual words in this scenario. In this way, we can perform the one hot encoding for the given text data. Similarly, we can apply the one hot encoding with the help of scikit-learn as well. Just like I've generated the integer value in this scenario, I can generate the integer values for the string data with the help of encoder. So I've just created my overall data, which is just the combination, okay, which is just the combination of corpus 0, 1, 2, which is nothing but the individual Python list. So I'm going to display my overall data. So this is my overall data would look like. Next, on this data, I'm going to apply the label encoder and convert the data into a numerical format, that is integer format. So this is how we can convert the text data into a numerical format, in this example integer. And if I want to convert it into the one hot representation, we can make use of one hot encoder, perform the fit on the data set and generate the transformation. Now remember, in the scenario of one hot encoder, we generally do not use it directly from the scikit-learn. The reason because the scikit-learn's one hot encoder implementation is created for the structured data, not for the unstructured text data. I've just used this example only to demonstrate as how does an one hot encoding would look like. All right. So we have now looked into the scenario of generating and having this text data represented in a numerical format. All right, team. Now moving on, let's look into the disadvantages that we find whenever we apply this one hot encoding technique. See, one major disadvantage is the size of my one hot encoding vector. Now the size of my one hot encoding vector is directly proportional to the vocabulary, the size of my vocabulary. And if I have a data set which has got very large vocabulary, for example, if I have got the data set and there are, let's say, 1 million unique words in my vocabulary, then in such scenarios, each word is represented in the format of a vector which has got 1 million entries, and where only one element will have the value as 1 and rest everything will be equal to 0. So as a result of this will result in the sparsity when we are representing the data. Now, when sparsity comes into picture, obviously this would lead to inefficiency when it comes to storing, inefficiency in computing, as well as learning the pattern from the data set. So this is one major disadvantage that we have got when we are working with this one hot encoding technique. And the another major disadvantage that we feel is there's no sequence of words when we are creating this one hot encoding. The sequence of words will be ignored. So that's another disadvantage that we have got when we are working with the one hot encoding representation. And if I come across any new word which is not present, which has not been learned, in such scenarios, I will not have an efficient way of dealing with those new words which are not present in my test data, that is on my training data. And also, when we are working with NLP, the context, yes, context in which how the words are being used is also not considered. So these are some of the main disadvantages of this one hot encoding technique. All right, team. So with this, we come to the end of this video. Now in the next video, we are going to look into another technique that's called as bag of words technique, which is better than the one hot encoding technique which we have seen just now. So I'll see you in the next video. Hey everyone, welcome back to your learning journey in this natural language processing. Now in this video, we are going to learn about the technique that's called as bag of words technique. So as we proceed in this video, we will understand what is the concept behind this bag of words technique, the intuition behind this bag of words technique, and we'll take up an example to understand this bag of words technique, and at the end, we'll also look into the advantages and the disadvantages of this technique. So let's get started. Now, when we talk about NLP pipeline, so as you know already, NLP pipeline is a step-by-step processing of the text data. Now, there are various components in this NLP pipeline. We've got the data collection or acquisition, text cleaning, pre-processing, feature engineering, modeling, evaluation, deployment, and monitoring. Now, this part of feature extraction comes under the feature engineering technique. See, when we talk about the first step, that is the data collection, we have already done the hands-on in our previous sections where we have extracted the data using the Scrapy. So that gave you an overall insight as how we can extract a text data. And then text cleaning is nothing but converting the data to the lowercase and removing some stop words from all those text data, and also apply the pre-processing techniques like the stemming and lemmatization and work with the text data in an efficient way. Now, before we start modeling, the feature engineering comes into picture. Now, this is a step where we will be interested in representing our text data into a numerical format. Now, in this journey of feature engineering or feature extraction, we have looked into the technique of one hot encoding in the last session. That is the one hot representation. Now in today's session, we will look into the another feature engineering technique that's called as bag of words technique in the natural language processing. So let's understand what is this bag of words technique in natural language processing. Now this bag of words technique is a classical text representation technique, and this has been commonly used in natural language processing. Here, this is a method of feature extraction or feature engineering that we perform with the text data. Now what we do is, here we are going to represent the text that describes the occurrence of words within the document.
So the key idea behind this is we are going to represent the text under the consideration as a bag. Okay, so represent the we'll just represent the text under the consideration of the bag of words. Now here when I say bag, it is just the collection. Okay, so when I say that if I've got a bag, okay, so I'm just going to consider that, okay, I'm going to classify my text data based on the occurrence of words, and I'm not going to consider the structure of the words. The basic intuition behind is that it is going to assume that the text belonging to the given class in my data set is characterized by the unique set of words. To give you an example, let's say I've got a text data, and this is a text data of a positive review. Here I've got a text that says as movie was excellent. So what it says is, if I've got a text that says as movie as excellent and another text that says as a movie was bad, okay, so what it considers is, in the scenario of bag of words, I'm going to say that, okay, if I've got the collection of words, irrespective of how the words are being used, I'm going to classify on the basis of the occurrence, not as where it is present in the document. Okay, so which means that movie was bad is obviously a negative sentiment. So if I have the word bad, it will be in one bag, and if I have the word excellent, it will be in a separate bag. Okay, it will be in a separate bag, which means I'm going to consider the words whether it is present or not without identifying or without worrying about the overall way in which those words are being used. That's the overall intuition behind this bag of words technique. Here, it assumes that the text belonging to a given class in a data set is characterized by the set of unique words. For example, if I've got the sentiment analysis text data, which means a review data, so all the text which are belonging to a class of positive, okay, so this will have some set of words, and all the text which has got the negative sentiment, it has got its own set of words. Okay. Now, based on this assumption, this bag of words technique is going to use. It says that if two documents, that is, if two sentences have nearly same words, then they would belong to the same bag. In other words, that is class. Just take an example. It says Harry Potter was good. Movie is good. So if I've got two sentences like this, okay, I can observe that both the sentences are having the same words or the similar words. So what it says is both the sentences will belong to the same bag. In other words, that is class. In this scenario, it's pretty visible. So both the sentences are the positive review of the movie. So this is the overall intuition behind this bag of words technique. So overall, I can say that by analyzing the words that is present in a given text corpus or a document, we can identify the bag or a class it would belong to. Hence, we call this term as a bag of words technique. Okay, this is the overall idea behind this bag of words technique. Now, in order to understand this bag of words technique, so let's take up an example data set. Here, let's say I've got three documents that are present in this data set. I've got S1, which says dog eats meat, and I've got S2, which says man eats meat, and S3, the sentence 3 here says meat eats dog. So I've got three sentences in this given data set. Okay, now if I go ahead and represent the text data with the help of one hot encoding, then this is how the one hot encoding would look like. So dog eats meat and man. These are the unique words that I've got in this data set. Dog eats meat, man. Okay, now depending on the words that are occurring, so dog is present one, eats meat, man.
Okay, man eats meat. Meat eats dog. Okay, so this is the one hot representation of my individual sentences. Here, I have mentioned as whether the particular word is present or not, which means here my sentence 1 is represented as 1110, which says what are the words that are present in this given sentence. So I'll be representing as whether it is present or not by merely saying in the format of a binary format, that is zeros and ones. So this kind of structure is called as bag of words structure. So I look into my data set, and once I look into my data set, I'm going to tell, okay, whether it is present or not. So that is the core principle behind this bag of words technique. So by analyzing this one hot representation together, I'm going to say that the assumption is if two sentences has the similar words or the same words, then both of them will belong to the same class or the same bag. That's the principle behind this bag of words technique. Now that you have understood the how easy it is and effective it is to represent this text data in a much more better way compared to the one hot representation, let's look into the advantages of this technique. See, as you have clearly observed, it's very simple to understand and it's very simple to implement. And it says documents having the same words will have the same representations which are closer to each other. And here, when we talk about the length of my individual vector representation, it will have a fixed length encoding of any sentence of the arbitrary length. Because here, the length of my vector is dependent on the length of my vocabulary. Now coming to the disadvantage of this bag of words technique, the size of the vector increases with the size of the vocabulary. Now, even in this scenario, we still have the sparsity for a very large vocabulary. And even in this scenario, it does not capture the different words and as well as the context. It does not have the ability to capture the context. For example, if I have the words like I ate, I eat, I ran. So in these scenarios, okay, so all the sentences, so ate and eat, obviously they are similar together. But when I have a vector representation, so it will not be able to represent it in that format. And even when you look into the similarity between eat and ran, so even in that scenario, the eat and ran, okay, both eat and ran will have the equal distance. That means the distance between eat and ran and eat and ate will be the same. It will not be able to capture the context in which the words are being used. So hence, we cannot find the relationship between the words when we are working with this bag of words approach. Alright, so with this, we come to the end of this video. Now, as we proceed in our learning journey, in the next video, let's see how we can implement this bag of words technique in a hands-on manner. So I'll see you next time. In this video, let's go ahead and implement the bag of words technique in a hands-on manner by writing the code in Python programming language. So as we progress, we'll implement this bag of words technique and then we'll look into the techniques that's called as bag of n-grams and its advantages and its disadvantages. So let's get started. So let's start by implementing this bag of words technique in a hands-on manner. For that, I'll quickly start my Google Colab. Here, we'll take up an example text data. I'm going to consider three text reviews like this. So I'll start by importing the necessary libraries. So import pandas as PD. I'm going to import numpy as NP. I'll say import collections. Now for the demonstration purpose, I'm going to consider three documents. I'll say doc1 is equal to Harry is an amazing movie. Okay, I'm going to mention my document 2. It says Harry Potter is the best movie. Okay, next I'm going to say document 3 is equal to Harry Potter is so Great. Okay. This is how the three text documents that I've got in this data set. So once I've got the data set, the next thing that I'll do is I'll perform the data cleaning and the pre-processing. Now in this scenario, I'll just go ahead and I'll remove some special characters that I've got over here, and I'll also ensure that I'll convert the text data into a lowercase, and I'll perform the split. That means I'll perform the tokenization. In order to do the same, I'm just going to write it like this: doc1 is equal to, I'm going to make use of regular expression, so I'll say import re and re dot sub, and inside the parenthesis I'm going to mention my regular expression. I'll specify like this. So I'm going to say a to z 0 to 9. Okay. Now once this is done, just going to replace it with blank, and I want to apply it on doc1 dot lower. Then I'll go ahead and I'll perform the split. Okay, once this is done, I'll say split. So this will remove the special characters and perform the tokenization. And I'll repeat the same process for each and every text document that I've got on this data set. So doc2 and doc3. Now once this is done, if I display my doc1, okay, so let's go ahead and see here. Okay, now if I display my doc1, this is how the doc1 would look like. Okay, so let me just modify a bit. I'll replace it with space. I think this will be a better one. So this is how my document would look like. So I have performed the data pre-processing, and then I have created the tokens. So that means I've splitted my text document into this individual words. Okay, I'll display my doc2 and doc3. So this is how my individual text documents would look like. Now, once I have got this text data, let's go ahead and perform the bag of words. Now, in order to perform this bag of words, first, let's get the unique words that I've got on this data set. So in order to get the unique words, I'm going to write it like this. I'll say all words is equal to doc1 plus doc2 plus doc3. So I'll perform the concatenation between all this Python list, and I'll convert it into the Python set. So this will help me to get the unique words that I've got in this entire text corpus. So these are the unique words that I have got in this text corpus. Okay. Now, once I have this unique words from this text corpus, we can now write the code like this. I'll create a new function def BOW representation. Okay, that's the function that I'm going to create. And here, this will get my all words as well as the document. Okay, so I'm going to get it like this. I'll say in this scenario, the BOW is equal to, I'm going to say dict from keys. Okay, inside the parenthesis, I'm going to mention my all words, comma 0. Next, I'm going to write it like this: for word in document. For each and every word that I've got in my text document, I'm going to say bag of words representation of that specific word is equal to document dot count, and I'll just say it as word. Okay, I'll just mention as how many times that word is being used. And finally, I'm going to return this bag of word. So once I've represented this, if I want to generate the bag of words representation for each and every document, I'll say BOW1 is equal to BOW representation. And inside the parenthesis, I'm going to mention my all words as well as my document one. Okay. Now let's test it whether it's working or not. If I say BOW1, see, this has generated the bag of words representation, which says whether a specific word is present or not. Okay. Similarly, I'll generate the bag of words representation for the second document as well as the third document. Okay, now once I generate the bag of words representation for each and every document, let's go ahead and construct a data frame. For that, pt.data frame, and inside the parenthesis, I'll mention this BOW1, BOW2, and BOW3. Now, once I represent this data frame of bag of words, this is the bag of words representation of my given text corpus that I've used in this given data set. So this is a simple way of representing the text data by checking as whether the word is present or not. Okay, now let's go ahead and implement this with the help of scikit-learn library as well. So if I want to implement the same with the help of scikit-learn library, first we will make use of count vectorizer. So here from sklearn.feature underscore extraction dot text, I'm going to import count. Now once I import it, I'm going to say cv is equal to count vectorizer. And while initializing this count vectorizer, the common practice that we mention is we will say binary is equal to true. Okay, because I'm interested in getting whether the text data is present or not, whether in my given bag, whether the word is present or not. So hence I'm specifically saying that binary is equal to true. Now once that is done, so I can just go ahead and apply it on my given data set. I'm going to say CV is equal to, so in this scenario, so I have mentioned as CV underscore out is equal to CV dot fit underscore transform, and I have mentioned my string data. Now remember, when we are passing the data into our count vectorizer, we don't have to perform the pre-processing. We have to send the data as it is. The scikit-learn library itself is going to perform the tokenization, and then it will generate the representation for the given data set. So currently it says it's in a sparse format. I'll say to array, and this will help me to generate the data in a one hot encoded format. Now to get the clear idea, I'm going to generate a data frame, and I'll say cv underscore out, comma, and for columns, I'm going to say cv dot get feature names out. Okay, now here in this scenario, I'll get the output. Currently it says shapes. Okay, let's go ahead and fix the same. So here pd.data frame I've converted to an array, and I've mentioned the column names. See, this is how the count vectorizer output would look like. So we have got the similar output just like what we have got earlier. Okay, in this way we can apply the bag of words technique when we are working with the text data. Now, one important point that I want to highlight, especially from the project implementation, is in this example, I have mentioned as binary is equal to true. Now, this is an approach that we use, especially when we are working with the data which are specific to sentiment classification. In the normal scenario, so what we will do is we'll not mention this as binary is equal to true. So what this is going to do is this will perform the counting. This will perform the counting of how many times word is being used. To give you an example, I'll say Harry Potter is an amazing movie, and I'll just say comma Harry. Okay, I'll just use the word Harry another time. So that means in the first document, I've got the word Harry present 2 times. Now this time, if I go ahead and perform the same activity of applying the count vectorizer and then displaying it as a data frame, so you can now see that instead of Harry as 1, I have the value as 2. That means this is going to describe the count as well, how many times that particular word is used in a sentence. Okay, so this is the overall idea behind the implementation of this count vectorizer. Now in this example,
So we have implemented this count vectorizer, that is bag of words technique, by considering my individual tokens. Now, sometimes having an individual token, that is having a single token, might not be sufficient when we are working to understand the overall structure in the data set. In such scenarios, what we can do is we can combine more than one word. Okay, we can combine more than one word and generate its representation. So in such scenarios, we can have a bigram, trigrams as well when we are representing the data with the help of this count vectorizer technique. To demonstrate the same, here I'm going to say ngram range. Okay, we like when inside this count vectorizer, we have the option to specify the ngram range. So by default it is unigram. Now if I want more than unigram, I can mathematically specify it. So I can say 1 comma 3. That means this is going to consider unigram, bigram and trigram. Unigram, bigram as well as the trigram. So if I execute this, see, I've got amazing movie, Harry. That means I've got the unigram, bigram, trigram representation for each and every document in this given data set. So with this, I'll be having much more better representation of the text data. But by having more features, so this has increased the complexity. This time with having the unigram, bigram and trigram, the number of columns has been increased to 31 from the previous number of columns, that is 1 2 3 4 5 6 7 8 9 10. From 10 it has been increased to 31. Now remember, and just think about as what happens if you have got 1000 columns. So if with 1000 it might directly shoot up to 10,000 as well. So always be careful when you are using more than bigram. So from the project implementation perspective, generally we stop at trigram, or even if the features are going out of hand, we will stop at bigram itself. Okay, so what we have seen is we have seen the hands-on implementation of bag of words technique by writing the code in a Python programming language, and also usage of count vectorizer with binary as true, and implementation of count vectorizer by specifying the counts in which the tokens are being used, and also extending it for unigram, bigram, trigram and the required ngrams. All right. So this was the implementation journey that we had in this video. Now coming back to our learning journey over here. So we have seen the representation of this text data in the format of bag of words, and also we have represented for the n-grams as well. Now by extending the unigrams to n-grams, okay, we were able to capture the context and the word order information in the format of n-grams, but this resulted in the increasing number of columns. That means as the n increases, then in such scenarios, the dimensions or the sparsity is going to increase. And even in this scenario, we have the issue related to out of vocabulary problem. And one thing that is advantage over here is, so documents which are having the same n-grams will have the vectors closer to each other in the Euclidean space as compared to the documents with completely different n-grams. So these were some of the advantage and the disadvantage of using the n-grams approach in the bag of words technique. All right, so with this, we come to the end of this video. In the next video, we will look into the another text representation technique, that is TF-IDF technique. So I'll see you next time. In this video, we are going to learn about the TF-IDF, which is also known as term frequency inverse document frequency. So as we proceed in this video, we will look into the concept of TF-IDF, the core intuition behind this TF-IDF technique, and we'll take up an example for implementing this TF-IDF technique to get the clear understanding as how this TF-IDF technique is going to work. So let's get started. Here, when we talk about this TF-IDF technique, TF-IDF technique, as I clearly mentioned here, it stands for term frequency and inverse document frequency. This is actually a technique which will help us to quantify the words in the set of documents.
Now, in the previous approaches that we have discussed, so in all those previous approaches, it could be one hot encoding, bag of words, or even in the scenario of count vectorization technique, in all those scenarios, we have represented the text document and each and every word in my text document is having an equal importance. But this TF-IDF technique is going to quantify the importance of a given word which are relative to other words in a document and the other words that is present in my document corpus. So it considers as how a particular word is actually very important compared to the words in the same document as well as compared to my entire corpus. So this method is one of the most widely used technique in the information retrieval as well as the text mining. To help you understand this, let's say I've got a sentence. The sentence which says that the building is so tall. So if I've got a sentence that says as the building is so tall, it's very important and it's very easier for us as a human being to understand which part of these words are very important for me. Now to give you an example, if I say the sentence like this, okay, the dress is so beautiful. Okay, this is an example sentence that I have got. Now when I have got this sentence and when I read this sentence as a human being, it's very easier for me to understand, okay, what are the important words that are present in this given sentence. Dress and beautiful, these are the two words which are very important for me. But the question is, how can my computer can understand, okay, these two are the important words compared to the every other words that I've got in the sentence. And the another challenge is, how can I ensure that these importance are actually carry forwarded when we are representing the data in the format of numerical format? And that's where this TF-IDF technique comes into picture. Now in this TF-IDF technique, we generally use this TF-IDF technique and we represent it with the help of two terms, term frequency and the inverse document frequency. So these are the two terms in combination makes it TF-IDF. Here the T refers to the term or the word, D refers to the document, and N refers to the count of corpus, and corpus is nothing but the total document set. Okay, so corpus is nothing but the total document set. N refers to the count of corpus. D refers to the document, which is nothing but the set of words in a sentence. And T refers to the term that we are interested in. So this TF-IDF is made up of two terms, term frequency and inverse document frequency. Now that you have understood what exactly is this TF-IDF composition is, that is term frequency and inverse document frequency, let's understand each of this. Let's start by understanding this term frequency. So here, when I say term frequency measures the frequency of occurring of a word in a document. Okay, it refers to number of times a particular word appears in a document. You can think of it as a sentence. So number of times this particular word has been used in a sentence. That is what we call it as a term frequency. Now here, when I say number of times the word appearance in the document, let's take up an example. I've got a sentence that says as sun rises in east. Okay, and next it says Sun Pharma is an important company and sun rises in east. Now in this example, okay, the first sentence has got only 4 words in it, and in the second sentence I've got 1 2 3 4 5 6 7 8 9 10 11. Okay, I've got 11 words in this second sentence. Now in this scenario, let's suppose I'm trying to count as how many times the word that I'm interested, let's say sun word that I'm interested, is present. Then in such scenarios, in the first sentence, the word sun is present only once. In the second sentence, the word sun is present twice. So one thing is pretty much clear. So in a bigger sentence, there is a very high chance that the word might be repeated multiple times compared to the sentence which has got lesser number of words. So in order to do the adjustment, what we do is we are going to divide the term frequency by the length of the document, which means for the term frequency for the first sentence, I'm going to say it as 1 by 4 because I've got 4 words in the sentence. And for the term frequency for the second sentence, for the word sun, I'll mention as 2 by 11. So we are going to divide the number of times the words that are occurring in a sentence divided by the length of the sentence. In other words, count of term in a document D divided by number of words in a document. So this is called as term frequency of a specific term in a document D. Okay, so in this way, we will ensure that by normalizing the data. So here we will ensure that the bigger sentence and the smaller sentence are treated equally. So in this way, we will find the value of term frequency. Moving on, the other term which is what my TF-IDF is made up of is the IDF, which is nothing but the inverse document frequency. Now, consider an example. Let's say I've got a sentence that says as dress is beautiful. Now here the word is obviously is not adding any important information about my dress. So these words which do not add any information about my data set, so we call it as a stop words. So the common words like is, are, and, so these words are known as the common words, also known as the stop words. And these words, when I'm using it, there's a very high chance that it will be repeated multiple times in a given sentence. So here, if I simply consider the term frequency in such scenarios, then these words, that is, are, and, which do not really add any important value, will start getting the high importance. So the idea is we have to reduce the weightage. So in order to reduce those weightage, we'll start using this inverse document frequency. So let's understand what is this inverse document frequency. So inverse document frequency measures the informativeness. It understands, it helps me to give the information as how much information that particular word is actually carrying in my overall text document and the corpus. Now, when we calculate this IDF, okay, when we calculate this inverse document frequency, it is given by the function of, by the expression of n by df. So here the n by df is the formula for the inverse document frequency. Now, when we calculate the IDF, it will be very low for the most occurring words like the stop words. So in such scenarios, it will be very low because they are present in almost all the documents. So in such scenario, since n by df is going to give us a very low document, the practice that we do is we are going to take the log of that value. We'll say log of n divided by df plus 1. So this is the formula that we use in order to calculate the inverse document frequency. Okay, so we'll calculate the inverse document frequency of a term t, which is given by log of n divided by df plus 1. Now, once I have the IDF of a term as well as the term frequency of a term, I'm going to multiply together in order to arrive at the TF-IDF score, which is nothing but the multiplicative value of term frequency and the inverse document frequency, which is nothing but term frequency of t comma d multiplied with log of n divided by df plus 1. Okay, so here n by 2, total number of documents in a corpus. So here my df refers to number of documents with term t. So this is how we are going to calculate the value of TF-IDF score. Now that you have understood how does this data would look like, okay, how do we generally calculate the TF-IDF score? Now let's go ahead and let's perform this activity of calculating this TF-IDF score. In order to calculate this TF-IDF score, I'll go ahead and I'll open my OneNote. So here I've got three sentences: man eats pizza, dog eats pizza, and ant eats food. So these are the three sentences that I've got on this data set. So in order to generate this TF-IDF score for each and every term, let's consider the sentence one. Okay, so here for the sentence one, so first thing that I'll do is along the columns, I'm going to list down the unique words that I've got in this overall text corpus. So man eats pizza, dog, and food. Okay, this is how the overall sentence one columns would look like. Now on this column, okay, for each and every term, I'll calculate the TF-IDF score. So for the term man, okay, I'm going to say S1 man. So if I look into the word man, man is present overall once. So TF, that is the term frequency, is given by number of times man is used divided by total number of words, which is nothing but the 3. And IDF is given by number of words, that total number of documents that I have got in the text corpus. In this scenario, in my text corpus, I have got 3 documents divided by number of documents which contains term T. So in this scenario, I have to find the number of documents which contains the man, which is given by 1. So I'll say IDF is given by log to the base 2 of 3 by 1. So let's go ahead and calculate the IDF score, that is a TF-IDF score for this example. So here I'm going to say import math.log 3 by 1. So this will help me to get the value of IDF score. So 3 divided by 1, actually 3 divided by 1 plus 1. So since we have got 1 already over there, okay, DF plus 1, so it's actually 3 by 2. So let's calculate the same. So 3 by 2. So in this scenario, so if I go ahead and calculate the same, I've got the output as 0.454. 0.454. So this is multiplied with 1 by 3, which is nothing but 0.454 multiplied with 0.33. If I multiply this together, we'll get the TF-IDF score for the word man as 0.14982. 0.14982. This is the TF-IDF score for the word man. Similarly, let's calculate the TF-IDF score for eats. So I'll say S1 eats. Okay, first is term frequency, it is the same 1 by 3. Now this time for finding the IDF, okay, log to the base 2 of what is the number of documents that I've got, that is 3. And this word, that is eats, is present in all the sentences. So the total number of documents where the word eats is present is 3. So 3 divided by 3 plus 1. So if I calculate it, 3 divided by 3 plus 1 and substitute over here, that is math.log of 3 divided by 4. So this has score as, like I'm getting the score as minus 0.28. Minus 0.28. So if I multiply it together, minus 0.28 multiplied with 0.33. So this is given by minus 0.09. So what it clearly says is, if I've got a word which is present in my sentence and it is present in every other sentence, this clearly is not a non-important word. That is what this overall TF-IDF score is telling me. This man, the word man, is present only in this sentence and not in every other sentence. Hence, the TF-IDF score for this man is very high compared to the word eats, because it is present in all the other sentences. Similarly, if you calculate for the word for pizza, in that scenario, it will be logged to the base 2 of 3 by 3 because it is present in two documents. So if I straight away go ahead and compute the same, that is 0.33, that is the term frequency, multiplied with math.log of 3 by 3. So here I'll get the TF-IDF score as 0, which is much greater than eats and less than the word man. The reason that is greater than eats because this word pizza is present in only in 2 sentences and not in 3 sentences. So it is worse than man because man is present only in 1 sentence. That's the core concept behind this TF-IDF score. This is going to give more importance for the word that is repeated in a specific sentence but not present in any other document in my text corpus, which makes it a very important word in that given sentence. So that's the core intuition behind this TF-IDF score and how to calculate it in a hands-on manner. So with this, we come to the end of this video. As we progress in our learning journey in the next video, we will implement this TF-IDF score in a hands-on manner using scikit-learn library. So I'll see you in the next video. Welcome back to your learning journey. Now in this video, let's learn how to implement the TF-IDF technique in a hands-on manner. So as we proceed in this video, we will see how we can implement this TF-IDF technique, the advantages of this TF-IDF technique, and the disadvantages of this TF-IDF technique. So let's get started and let's start by implementing this TF-IDF technique. Now when I say TF-IDF technique, so here one differentiator between this TF-IDF technique and the count vectorizer technique, which we have seen in our previous learning journey, is in the scenario of this TF-IDF technique, I'm going to provide more importance to the word which is present in a specific document and which is not present in any other document. So what is a document? Document, you can think of it as a sentence. So if I have a word present and repeated multiple number of times in a specific sentence, and not present in any other sentence in my overall text corpus, that is when I'm going to add more score for that specific word. So when I do it in this way, okay, so I'll ensure that whatever the stop words that I'll have, so in the scenario of stop words, okay, so this stop word is a word which is repeated most number of times in my current document and it is also present in every other document, hence score will be less. Now, if I have a unique words, okay, unique words repeated in a sentence, but not present anywhere, in that scenario, score will be high, which means only in that document I see that appearance of the word. Now, let's suppose I'm talking about a specific term, let's say neural network, okay. If I have a word neural network, so if I have this overall term of neural network, and if this term of neural network present in one document, that is one sentence, and if it is used multiple number of times, and if it is not present in any other document, then I'm going to assign higher score for this word neural network compared to the other words, because that is a document has the neural network quoted multiple times. So that is how the information extraction application can be built around using this TF-IDF technique. Okay, this is the overall idea behind this TF-IDF technique implementation. Now let's go ahead and implement this in a hands-on manner. In order to implement this in a hands-on manner, I'm going to import the necessary libraries, import pandas as PD, and I'm going to import math module, and I'm also going to import the sklearn library as well. Okay, once I do the necessary imports, I'll just get two sentences. I'm going to mention my first sentences is equal to, I'm going to say data science is an amazing career in the current world. Okay, and I'm going to have a second sentences. The second sentence is given by deep learning is a subset of machine learning. Okay, so this is how the two sentences that I've got over here. Now the first thing that we have to do is we have to perform the tokenization. Now for the example purpose, we'll take up a very simple tokenization method. So I'm going to do the tokenization by splitting the data with the help of spaces. So I'm going to say first sentence is equal to first sentence dot split, and I'll split on the basis of space, and I'll repeat the same activity for my second sentence as well. So once I split on the basis of spaces, the next thing that I have to do is I have to get my vocabulary. So in order to get my vocabulary, I'm just going to convert both the first sentence and the second sentence as the Python set, and I'll take up the union between them. Okay, union second sentence. Okay, and finally I'm going to display my vocabulary. So this vocab is a variable contains the complete vocabulary, the unique words that I've got in this given data. Okay, now once I have this unique words, so what I'll do is I'll just go ahead and I'll add a count, which means I'm going to count the words using the dictionary key value pair. So I'm going to say word dictionary A, okay, or word dictionary 1. I'll call it as word dictionary 1, and I'm going to say it like this. I'll say dict dot from keys, and here I'm going to mention my vocabulary comma 0. Then I'm going to say word dict 2, okay, so dict dot from keys. Here I'll mention the same thing, vocabulary comma 0. So as a result of this, okay, let me show you what is the overall output that I'm getting. My word dictionary 1 contains a simple Python dictionary that look like this, with every key is nothing but the keys from this vocabulary. In the same way, I've generated the word dictionary 2. Now using these two variables, word dictionary 1 and 2, I'll go through each and every sentence, and I'm going to count as how many number of times a particular word is being used. So I'm going to write it like this. So it's a very simple for loop. I'm going to say for word in first sentence, and I'm going to write it like this. I'll say word dictionary 1, and I'll get an individual word. I'll increment it by 1, and I'll repeat the same thing for the second sentence as well. So word dictionary 2 and word plus 1. Okay, so in this way I'm going to perform the activity. Now if I describe my word dictionary 1, so this has got the overall output. It says how many number of times a particular word is being used in that specific document. Word dictionary 1 and word dictionary 2. So interestingly, if you observe the word dictionary 2, I've got the learning used 2 times. The reason, because if you look into the second sentence that we have got, in the second sentence, I've got the learning word is being present 2 times. Hence, you would see the count as 2 for the word of learning. Now, if I just go ahead and convert it into a data frame, this is very similar to the count vectorizer which we have implemented in the earlier section. So if I simply write as df is equal to pd dot data frame and mention as my word dictionary 1 and word dictionary 2, and if I describe this data frame, see, this is how my data frame would look like. This is a clear representation of the count vectorizer. Okay, now let's go ahead and write our custom function in order to compute the term frequency. Now what is term frequency? Term frequency is nothing but getting the count. So getting the count as how many number of times that particular word is being used divided by the total length of my corpus. So that is what we call it as a term frequency. So as we have seen earlier, term frequency is equal to number of or frequency of a particular word in a document, frequency of a word in a document divided by total number of words in a document. So this is the formula for term frequency. So let's go ahead and calculate the same. I'm going to say def calculate TF. Okay, so here this is going to get my word dictionary, and along with that this will also get a document. Now what I'm going to do is I'm going to write it like this. I'll say term frequency dictionary. I'll initialize it as a blank Python dictionary. Next I'm going to write it like this. I'll say corpus length of the corpus. Okay, length of the corpus is nothing but length of my document. So this is the length of my corpus. Next, for each and every word, for word, so I'll take the word as well as the count in this word dictionary. I think that will be a better approach. So for word comma count in word dictionary dot items. So for each and every key value pair that is present in this word dictionary, I'm going to mention like this, my TF dictionary. For this specific TF dictionary, the word as a key, I'm going to assign the number of times that particular word is being used, and this is being given by the count, that is the value in this word dictionary. For example, when I'm iterating for the word learning, I'll get the value as 2. So I'll take this 2 and I'll divide by the length of that sentence. So count divided by length of my corpus. That's it. That is what is going to give me the overall output. So that will help me to calculate the term frequency. Now finally, I'm going to return this TF dictionary. So this is what I'll be returning right now. Now once this is done, let's test it and let's see whether it is working or not. I'm going to say calculate TF, okay, and inside the parenthesis I'm going to specify the word dictionary. Let's say word dictionary 1, comma, I'm going to specify my first sentence, and if I execute this, so we have got the output in this way. So this is the overall output as a result of applying this calculation of this term frequency. Now I'm going to store it inside a variable. I'll say TF1 and I'll repeat the activity for TF2. So here I'm going to specify my second sentence. Now once I specify the second sentence, I'm going to convert it into a data frame. I'll say TF data frame. I'm going to mention these two dictionaries as an element inside my Python list. Now if I describe this data frame, this is how my data frame would look like. Okay, let's execute this. So we have the output in this way. So each and every element is having the value of term frequency. So one thing you can clearly observe, the word learning has the frequency as 2. Since it has the frequency as 2, when I do the normalization, I have got the higher score compared to the other words that I've got in this corpus. So in this way, we are going to compute the value of term frequency. Okay, now one more thing that we can actually do is, if I want to extend it, so instead of calculating the term frequency for each and every terms, what other thing that we can do is we can check the individual tokens and see whether it belongs to the stop words or not. If it belongs to the stop words, we can actually remove those stop words from the word corpus and then calculate the term frequency. Okay, so you know already how to remove the stop words from the previous section. So just to help you understand the same, I'll say import NLTK from NLTK dot corpus. I'm going to import the stop words. Next, here, once I import the stop words, I'm going to just display the stop words. Okay, stop words dot words. I'm going to specify the language as English, and if I execute this, this will display the overall stop words that we have got. So it is asking me to download. Let's download the same. See, these are the stop words that I have got from this NLTK library. Now, if I want, I can extend the stop words as well. So these are just the stop words that is provided by default. If I have my own custom stop words, depending on the domain data that I'm dealing with, then in such scenarios, I can also ensure that I can extend it by taking a set union and create my own list of stop words. Okay, so that is how we can do this same. So if I want to give you an example, I can write it like this. I'll say F1. Okay, so here I'm going to write it like this: for word, okay, for word in word dictionary 1, okay, if not in, I'm going to say dot words English. If the word is not present in the stop words dot English, then only consider that word.
So F1 will be an outcome of applying the filtering. In the same way, I'll do the same thing for the second sentence as well. F2 is equal to forward in word dictionary 1 if not in stop words. So just go ahead and do this filtering. So I just have to modify it by inserting the word condition. Okay. Now once this is done, if I display my F1, so this is the filter data, and if I describe my F2, so this is another filtered data. Okay, so F1, okay, word dictionary 1 and word dictionary 2. So I can mention it in this way. All right, team. So what I can do is, let me just modify it. So instead of saying like this, I'll say for word dot lower. We can also convert it into the lowercase. See, we can convert it into the lowercase and check whether it is in stop words or not. So in this way, we can go ahead and apply the filtering as per our requirement. So for now, I'll keep the same values as it is. So I'll assume that all the words are the important words. Now with this understanding, I'm going to create a function to compute the IDF. So I'll say def, okay, calculate IDF, and this is going to get a document. Okay, now what I'll do is I'm going to write it like this: IDF dictionary. Just like we have created the term frequency dictionary, I'm going to create an IDF dictionary, and here the length of my corpus, I'm going to write it like this: length of my document that I'm going to get. Okay, whatever the length of the document that I'll get the length. Now this time I'm going to create a dictionary. So here in this function, so I've got the IDF dictionary where I'm going to create a dictionary from the keys that I'm getting right here. So in order to calculate the IDF, so I'll go through each and every word and the value that I've got over here in this IDF dictionary dot items. For each and every word and the value that I have got right here, I'm saying that IDF dictionary word is equal to math.log to the base 10 of length of document divided by whatever the value that I have got right here. So I'm going to add it with 1. Okay, so what does the value contain? See, this value will actually contain the how many number of times that particular word is being used in that document. So I'm going to consider the total length of the corpus. In this scenario, the number of documents that I have got right here, the length of document. So what is the total length of document is nothing but the number of data that I'm sending it right here. So if I've got 2 sentences, this will be equal to 2. Okay, so the number of sentences that I've got in the corpus divided by how many number of times this particular word is being used. Okay, so this is going to return me the value of IDF. Now this function is the implementation of calculation of this IDF score. Now here, in order to calculate the IDFs, so I'm saying that calculate IDF, and I'm getting the values of this word dictionary 1 and I'm sending out my word dictionary 2. Now in this way, I'll go ahead and I'll calculate this IDF scores. So this is the IDF scores for each and every word that I've got right here. Now, when I say TF-IDF is nothing but computing the term frequency and the inverse document frequency and multiplying it together will give me the value of TF-IDF score. Now, in order to calculate this TF-IDF in this given example, so I've written a function which is called as compute TF-IDF. So here I'm saying that TF-bow and the IDFs, that means term frequency bag of words and the IDF scores that I've got. So these are the two things that I'll get as an input. Next, this is a blank Python dictionary. I'll go through each and every key value pair that I've got in this TF-bow, that is term frequency that I've got over here. So if you look into my TF1, that is actually my term frequency bag of words that I have got. So for each and every key value pair that I have got over here in this term frequency, I'm going to get the overall value of TF-IDF by multiplying the term frequency with its inverse document frequency. Okay, so once I do the multiplication, that will help me to return the value of TF-IDF score. And I'll do this activity for each and every data that I have got, that is for each of the term frequencies data that I have built earlier. And finally, I'm going to generate a data frame. So this is a data frame which describes the TF-IDF score for my given data. Okay, so in this way, we can write the code in Python programming language to calculate the TF-IDF score manually. Now, if you don't want to take this approach, obviously we've got an easier approach. The easier approach is with the make use of this sklearn library. So in order to implement this with the help of sklearn library, I'm going to import from sklearn.feature underscore extraction. I'm going to import TF-IDF vectorizer. So once I import this TF-IDF vectorizer, I'm going to get my first and the second sentence. See, this is my first sentence and I'll get my second sentence. Once I mention my both first and the second sentence, I'm going to call the vectorizer. I'll say VEC is equal to TF-IDF vectorizer. Okay. Next, once I define this TF-IDF vectorizer, I'm going to write it like this. I'll say my result is equal to TF-IDF vectorizer dot fit underscore transform, and I just have to send in both the data, that is first sentence and the second sentence. Then if I just display the output of this response, okay, so it looks like there's an error. Okay, this feature extraction dot text, that is where we have to import it. So now if I execute this, so I've got the output in the format of a sparse. So let's go ahead and so this will generate the data that would look like this. Okay, let's convert it into a data frame. So I'll say period.data frame and I'll specify this values, and then I'm going to say vector dot get feature names out. Okay, so this will be my column names. So if I execute this, this is going to create the data frame that would look like this, which will have the values of TF-IDF scores. Okay, so in this way, we can compute the values of TF-IDF scores with the help of scikit-learn library. Okay, so in the above one, so we have taken a manual approach at a very high level using our understanding. In the below approach, we have implemented it in a hands-on manner with the help of scikit-learn library. Alright team, so now that you have seen how we can implement this TF-IDF technique for a given text data, let's have a look into the advantages. See, one of the major advantage in this TF-IDF technique is we can use this to calculate the similarity between the two texts using the similarity measures like cosine similarity and the Euclidean distance, because we now have the vector represented with the help of real values. And as a result of this has got some of the applications in text classification, information retrieval, and so on. And this TF-IDF technique is clearly a better technique compared to the earlier methods that we have discussed. Now, talking about the disadvantage, well, in this scenario of TF-IDF technique, we still has the issue related to high dimensionality, because the number of columns in my data set is dependent on the length of my vocabulary. And here it is still the discrete representations of the text unit. Hence, as a result of this, we are unable to capture the relationship between the words. And there's also the sparse and the high dimension. Because of the out of vocabulary words, we'll also face the issues as well. Okay, so these are some of the disadvantages of this TF-IDF technique. Now that we have seen the disadvantage, so the other better method that we have got is the word embedding, which is what we will be learning as we progress in our learning journey, guys. So in the next video, we will get started with the next topic of word embeddings. So I'll see you in the next video.